Okay, welcome back to the Johnson Space Center with the continuation of our STS-110 pre-flight briefing. This briefing entails the extravehicular activities overview with our lead STS-110 EVA officer, Dina Barkley. Go ahead, Dina.
Thank you. Well, good afternoon. Our crew and our EVA team are ready and excited to conduct the upcoming 4 spacewalks on STS-110. From a big picture standpoint, there are really 2 major objectives of the spacewalks, and those are to get 2 major elements up and running. They're the F-0 truss elements that Ben gave you an excellent overview of, and also the mobile transporter, a remotely controlled vehicle that travels up and down the rails. The truss element has been called a Spacewalker's Playground, and we've nicknamed an underwater mock-up of it the Jungle Gym. It's about 44 feet long, has more than 150 astronaut handholds, almost 50 sockets for foot restraints for our astronauts' boots, has more than 1,000 spacewalker actuated connections, and has more than 50 boxes that can be changed out. And as you've probably been hearing, the truss plays a vital role in the space station's future, because future truss segments will attach to either side of it, and all the avionics and ammonia cooling that go out to and come in from the outer truss segments go through F-0 for power distribution and cooling for the modules in which our astronauts live and work. The mobile transporter also plays a key role. On the next mission, UF2, the next part of the mobile servicing system will come up, and it will mount on top of the mobile transporter to give Canadarm2 a mobile platform to finish the space station assembly. Before I get into the details of the spacewalks, I'd first like to say a few words about our fantastic team of astronauts and ground controllers that have a role in this flight. Steve Smith is EV1, and he has an impressive resume as a spacewalker and a payload commander. He was on 2 previous Hubble Space Telescope missions and has 5 spacewalks behind him. He's our lead EVA spacewalker, and he'll be performing the 1st and 3rd spacewalks on the flight. And he'll have red stripes on his backpack and legs. Rex Walheim is EV2, and he'll be performing his first space flight, and he's working with Steve on EVAs number 1 and 3. He'll be wearing an all-white spacesuit. And although he's rookie, he's certainly had his share of training, probably more than 100 hours underwater in the pool. Jay Ross is one of the most experienced guys in the astronaut office. He's got 6 space flights and 1,100 hours in space and more than 44 hours of spacewalking experience. And he's on the team opposite of Steve and Rex, and he's performing the 2nd and 4th EVAs. He'll be wearing the broken red stripes. Lee Morin is on Jerry's team, and this is also his first space flight, although he's trained quite extensively underwater as well. And he'll be wearing candy cane stripes on his suit. Carl and Dan Bursch, 2 of the space station crew members already on orbit, they'll be using their experience base from the EVA that was conducted on February 20th to sort of help the shuttle crew members learn the ropes with the space station airlock. And they also play key roles in the robotics world. One note of interest about our crew is that Jerry and Lee are both grandfathers, and performing a spacewalk is no easy feat. It requires mental and physical stamina, and these guys have it. So I'll just preempt the questions now that they're ready to go. And to our team, it's just a fun piece of trivia, and the only time it even comes up is when these proud grandpas pull out the photos. There's also another huge team of people that have come together to get this mission ready to fly. Our EVA team here on the ground is, to me, just as spectacular as the crew. Michelle Hollinger is a detailed EVA timeliner, and she's really the expert on the truss and the mobile transporter. Deb Scoville is the lead spacesuit instructor and flight controller, and he, along with Paul Bain, will be watching the Quest systems and making sure that the spacesuit's functioning nominally. Boeing's Eric Fukushima has really played a key role through the years in developing these spacewalks as well, and he'll be supporting during the mission. And I have to mention our Canadarm2 robotics guys in the control center. They've been working really long hours getting ready for this mission and for supporting the spacewalks. It's a team led by Royce Renfrew, and it includes Sanad Aziz, Christine Kennedy, and Andrew Klim. And this is just a few among many, many folks. So about the flight. For EVA, this flight actually begins before the shuttle even launches. A lot of the equipment that we'll be using for the spacewalks is already on board the space station. For example, Rex's spacesuit's up there, and there's several batteries that we use for the different spacesuit components. And most of the tools that the crew will be using and taking out with them are already on board the space station. On the shuttle, we'll be bringing up 3 more spacesuits, and those are for Steve, Jerry, and Lee. And we also have a few tools and some other EVA-related equipment that comes up. But since there's so much on orbit already, the Expedition 4 crew will be performing several activities in preparation for the 8A crew arrival, including general airlock preparations, configuring Dan Burst's suit to fit Rex, and then checking that out, laying out the tools that Steve and Rex will use on EVA-1, charging batteries, and checking out the jet backpacks that the spacewalkers will wear for self-rescue capability should they become detached from the space station. After the STS-110 launch and before shuttle docking to the space station crew will continue preparations, but in parallel, the shuttle crew will be doing operations on the shuttle as well. They'll be checking out the 3 spacesuits that they're bringing with them, and generally packing bags full of tools and EVA-related equipment so that post-docking they can quickly and efficiently throw those tools onto the space station side. And so all they have to do post-docking is really throw the items, not throw them, but hand those items through the hatch and do some final checks and mentally prepare for the following day, which is our big EVA-1 day. And that next morning after docking on EVA-1 day, Ellen and Dan will work right away to start installing the truss onto the U.S. laboratory Destiny using Canadarm2, and our spacewalkers will start their preparations. For the first EVA, Carl and Jerry will be helping Steve and Rex as they perform their oxygen pre-breathe while they're exercising on the bicycle. All 4 of them will go into the larger Quest volume and shut the hatch for a short time to slightly depress the volume and get Steve and Rex into the spacesuits. And the oxygen exercising and depress of Quest, they'll keep Steve and Rex safe from getting the bends, which is something that scuba divers can get when they're exposed to lower pressures. The F-Zero truss will come to rest on top of Destiny, and Lee will work to internally close the claw to hold F-Zero in place, and that's where the fun begins for our spacewalkers. The important parts of this spacewalk are really the 3 vital objectives. First of all, to apply power to the truss and to apply power to the mobile transporter and to structurally attach F-Zero to Destiny with 2 of the 4 strut groups that you've heard about. The other 2 strut groups are going to be installed on EVA-2, and once all 4 strut groups have been deployed, this set of rigid poles will allow future attachment of several truss structures for a total truss length of over 300 feet. So you can kind of imagine how vital these 4 strut groups are. So let's roll the video for this EVA. We'll start with a view of the International Space Station after the F-Zero truss has been installed. As we zoom in, F-Zero is the white shrouded truss sitting on top of the gray colored Destiny. The airlock Quest is in the lower left. And Steve will be exiting first, followed by Rex, who'll be getting his first glimpse of Earth from the outside. Rex will get on to Canadarm2 as a platform for their spacewalks. And the robotics involved here is pretty complex, and this is the first flight that we'll be using Canadarm2 as a work platform. Steve will have already started loosening the forward strut groups from the launch location. You can see the first strut group flashing. And he'll temporarily tie these off so that Rex can mate the struts to Destiny. To fully deploy a strut, the strut is telescoped out, mated to Destiny with 4 large bolts, and then rigidized by clamping the struts with mechanisms we call clamshells. About the 4 bolts on each strut group that Rex has to tighten to Destiny, their tightening sequence and torque method were carefully chosen, and they'll be using a power tool and torque multiplier normally. And if these don't fit on the bolts in the tight area they're working in, they'll use a long torque wrench. In this footage, you can see him using a torque multiplier as seen on one of the bolts. He's got a power tool in his hand there. The torque multiplier allows us to apply more torque than with a power tool alone. Steve doesn't have access, Steve will be accessing at this time the interior of the truss. So he'll go through this trap door in the white shrouds. These shrouds surround S0 on all sides except for the forwardmost face, which is left clear for the mobile transporter to travel back and forth. He doesn't have access through the front face, so he'll have to use the trapdoor here, and you can see the divers helping him in a little bit with his buoyancy. This is the first of 4 times that our astronauts will actually go inside the truss. This time he's going inside to release some clamps, which will loosen some lines and allow a large cable tray in the back to deploy. And on his way out, he'll close the shroud to protect S0 thermally. After he exits, he'll be deploying that cable tray in an area that we call the rat's nest. It's buried between several modules and trusses, and this area could be called the heart of space station for spacewalkers. It's where many electrical and fluid lines meet between the modules. Before we make any electrical connections, circuit breakers called circuit interrupt devices must be turned off with a simple switch throw. And this will guarantee that electricity won't be flowing through the lines that our spacewalkers are mating and demating. You can see I'm handling it here. You turn off a circuit breaker in your house before doing electrical work, and our house is no different. Next, we will be demating some cables that were mated on the last Expedition 4 spacewalk on February 20th. These cables proved valuable for checking out the electrical circuit that will power S0, but now Steve will tie these cables out of the way. The cables that Steve actually needs to mate here on the backside are launched on a tray that's flush with the truss structure, flashing, and Steve will release 2 bolts to lower the tray. The rectangular-shaped tray automatically latches open after he deploys it. He'll be standing in a foot restraint on S0 to deploy the tray and also to mate the cables. Steve will mate 10 cables from the tray to the Z1 truss and to Destiny. And there are also fluid lines and more avionics cables that are on this tray, but we won't be deploying them on this particular flight. Next is some footage from the Neutral Buoyancy Laboratory, and you can see why we call it the rat's nest. Steve's space is limited by trusses on either side of him, and there's a lot of cables to deal with. Reach and visibility to some of the connections can be somewhat difficult in this area, and it's tough to get a gloved hand in some of the spaces. And imagine yourself wearing a large pressure suit trying to squeeze into a small car, and that's what Steve is experiencing. On the forward side, Rex will also be working with electrical lines. He'll first remove a long tray from its launch location by releasing 6 bolts, and he'll place it on the starboard side of Destiny. He mounts to Destiny with 2 bolts, and he'll make 3 connections to the forward end of Destiny. An upper arm of the tray is hinged upward and mated to S0, where he makes 10 electrical connections. You can see it just opens there. And in a moment, you'll see him doing the same thing on the port side. The number of connections vary slightly between the port and starboard sides, but it's a similar operation. For both trays, Steve will come around from the rat's nest every so often to help with structurally mating the tray, and also to help Rex see his clearance between those long trays as he maneuvers between the Shuttle, Destiny, and the new S0 truss. Next, we have some Neutral Buoyancy Laboratory footage of one of the trays. The far end of the umbilical is thicker than the close end because the upper tray that hinges up to S0 is on that far end. You can see it, a diver on each end of the tray here. We often joke that it'd be nice to have divers in space helping us out like they do in the pool. But I can reassure you those guys won't be there in flight. You can see Steve waiting in the background on the left side of this video to help Rex mount the tray onto Destiny. He's back there next to the diver with the yellow tanks. I talked about circuit interrupt devices earlier, and Steve will actually be installing 2 of these new circuit breaker boxes inside of the truss if he has time on the CBA. If we don't have time to install them on the CBA, we'll do it on the 3rd spacewalk. And one of them is just about to pop into the picture. You can see it there. These devices allow future flights to break electrical circuits in the middle and reduce the amount of space station power down that's required during later assembly missions. And the cables that he'll be working with are pretty large, and he'll need all this muscle to install them. Next, Steve and Rex will work together on supplying the mobile transporter with its heater power via the trailing umbilical system that Ben talked about. The cable is half the length of the space station truss at assembly complete, and it's all coiled up inside a large reel on the far starboard side. Steve will be pulling the cable out of the reel, and then Rex will pull it to the port side and mate 3 connectors to the mobile transporter. Steve here is in the foreground, and Rex is in the upper left corner. They'll be deploying about 20 feet or so of cable, and they place the cable in guides along the rail to keep it close to the rail and on track. So as the mobile transporter moves along, it opens and closes these guides. And after this spacewalk, Steve and Rex will get out of the spacesuits, and then the crew will transfer Steve and Rex's spacesuits to the shuttle and start charging some batteries. The following day is a non-spacewalk day, and our crew will be busily preparing, though, for the next 2 EVAs that follow. Spacewalks 2 and 3 occur back-to-back on consecutive days, and which is a first for space station-based spacewalks. So on this off day, they'll be transferring Jerry and Lee's suits over from the shuttle, checking them out in Quest, and reviewing procedures for both of the next 2 EVAs. And that next morning, it's Jerry and Lee's turn to go outside. The critical tasks of that day are, first of all, to deploy the 2 remaining strut groups, and these are tripods, as you saw with Ben's graphic. And they're somewhat like a camera tripod. You lengthen each leg, and then you rigidize the interface to keep it from being able to extend or contract. Second, we'll be clearing off the front face of S0 to allow the mobile transporter to move back and forth after EVA 1. To clear off the rail, we need to remove and stow 2 beams called drag links, and 2 A-shaped or triangular-shaped structures called keel pins. These items were all required to stabilize S0 in the payload bay for launch, and now they're just in the way. The last major goal of the spacewalk is to attach a second trailing umbilical system cable to the mobile transporter to provide power data and video redundancy. And so we're ready for the video for EVA 2. Jerry will exit Quest first, followed by Lee, and Lee will hop on to Canada Arm 2. Right away, Jerry is going to start loosening bolts on the aft strut groups while Lee gets into position for the first deploy. Flashing on the screen is the first strut group on the starboard side next to the airlock. Lee will be at the S0 end, and he'll release the last bolt to finally loosen the struts. And Jerry will receive the pointed end of the tripod at Destiny. Both of them will soft mate their ends, and then Lee will be fastening 6 bolts to S0, and Jerry will fasten 5 bolts to Destiny. And then they'll later fasten clamshell bolts, which will be tightened to hold these struts rigidly. And this is an action shot of the deploy. Lee's in the foreground, and the pointed end of the tripod is in the upper left-hand corner, headed down towards Jerry. The 3 telescoping struts of the tripod are extended and contracted to form its prism shape. You can see it extending here. And this is Jerry's end of the job here. And he'll pull the tripod into place, and then he'll mount it to Destiny. He's struggling with the mock-up just a little bit, but you can see how he'll make his side of it. Ellen will then drive in a large Canadarm2 maneuver around the underside of Destiny, and Leo will get a great view as he travels over to the port upstrut group. This task is a mirror image of the starboard side. And like EVA 1, they'll be performing a special torquing sequence at each of the strut group's feet to make sure we get a really sound attachment. And next, Jerry is still free float, and he'll detach the starboard drag link, it's flashing on the screen, from the triangular keel pin and S0, and he'll stow it in the location that you see there. And drag link is just a fancy name for this long structural beam. Then Rex is going to come over on Canadarm 2, and he'll pick up the port drag link and take it to a similar stowage location. This drag link was actually released on EVA 1 by Steve, who needed to get inside the truss to install the circuit breakers. And Steve had left it on the port side in a temporary location. Next is some NBL footage so that you can see what a drag link looks like. It's just a beam, as I said. And this is a shot of Jerry stowing the starboard drag link free float. Also, while Jerry's on the forward face, he'll be removing a blanket that's in the way of mobile transporter translation up and down the truss. And they'll meet back up and deploy the second trailing umbilical system cable. This one's more nadir, closer to Destiny, than the one that Steve and Rex deployed on EVA-1. Jerry will be at the cable reel pulling out the cable, and Lee is on Canadarm2. So this is a good overview shot so you can see the distances involved. Jerry and the reel are on the far left, and the mobile transporter is on the very far right, and Lee is on Canadarm2 in the center of the screen, moving towards the right. To finally clear off the mobile transporter rail so that it can translate down the truss, these A-shaped keel pins will be removed, and they're each attached with 2 bolts to the truss. They're stowed on the starboard wedge face, we call it, and so the crew's got quite a long way to maneuver the Canadarm2 in order to stow this keel pin. And we've worked pretty hard in our choreography of our spacewalks to keep those long maneuvers like this down to a minimum. The starboard keel doesn't take nearly as much maneuvering. Each keel pin stows with a tip pin onto the truss. Here you can see Jerry at the top releasing the last bolt on the keel pin, and Lee is holding the keel while he stands atop Canadarm2. But you can see the end of Canadarm2 our mock-up in the lower right corner. And there isn't much time left in the day to get ready for the next day's spacewalk, so the crew will be concentrating on the bare minimum. They'll be retrieving Steve and Rex's suits from the shuttle and placing them in the station airlock and prepping the tools for the next day. The third EVA is performed almost entirely without Canadarm2, and that's because the main purpose of the spacewalk is to configure the cables that need to be rerouted for Canadarm2, and so it needs a break from operations during that time. So the shuttle's robotic manipulator will be used as the work platform to perform those operations. In addition to Canadarm2 reconfiguration, another major objective is to release the mobile transporter launch locks, which were needed for launch but now need to be released to allow the mobile transporter to move up and down the rails. They'll also be transferring tools and deploying a long beam with handrails on it that will aid future spacewalkers. So let's roll the video for EVA-3. For this spacewalk, Rex will exit Quest first, followed by Steve, and this time Steve will be on the robotic arm. One of the first items of business is to relieve loads by opening the claw inside this white structure, which was used as F-Zero's initial attach point to Destiny. Then the crew will make cables and to begin readying the robotic electrical and video systems to later allow Canadarm2 operations in its new home on the mobile platform on top of F-Zero. So here we open a panel called the J300 panel. We made the cables, and the panel is closed again. Then we'll move down to an area called the J400 panel. The area is covered by 2 panels, actually, the first of which the crew will open to configure Canadarm2's primary power. These panels all come off completely using a special tool, and it's tethered off to a handrail to hold them out of the way. Next is some on-orbit footage from STS-100. This is when Scott Parazinski and Chris Hadfield brought Canadarm2 to life. This gives you some perspective on how many cables there are in the area. Some of the lines here are thin fiber optic lines, and like he's holding one, in fact. So the crew has to take care when they're handling them not to bend them too severely. Now while the ground tests out the connections that our crew's just made, the crew will go and release several launch locks from the mobile transporter, and they will remove a small blanket. Some of the bolts will be actuating carefully seat the wheels on the track that Ben was talking about previously. Then we'll head back over to the J400 panel area, this time to reconfigure the backup Canadarm2 power and switch a data path. Some connections are under the previous panel, and 2 of the connections are under a second panel, just closer to the base of the arm. After these connections are made, the robotics folks will perform some commanding and verifications and make sure Canadarm2 is functioning properly with its new electrical routing. We want to use Canadarm2 at the end of the EVA, so we'll be listening closely to see how it's going. And while this is happening, the spacewalkers will be doing a tool shuffle. They'll meet up at a bag that's filled with tools, seen flashing. And they'll put new tools in the bag and take different tools out. They'll spend some time picking up tools that are in a few locations around station. As part of this task, Rex will retrieve some tools from the shuttle cargo bay, and this is the only time our crew will go into the shuttle cargo bay, and he'll put those tools into that bag. Some tools will move to the toolboxes that are shown flashing on the side of Quest, and some other tools will actually be coming inside. Lastly, they'll be deploying what we call the airlock spur, and this is just a beam that deploys from the truss to Quest. Steve will be on Canadarm2 for this task. On this side, I'll also depress 3 sensors that will be used on a later flight just to make sure they're working. Here's the airlock spur. It's a beam with rows of handrails. And as future crew members exit the airlock spur will give them an uncluttered and direct path to S0. It's also a nice path back to Quest at the end of the spacewalk. After this EVA, the crew will get out of the suits and save most of their work for the following non-spacewalk day. That next day, the crew will move Jerry and Lee's spacesuits back to the space station, transfer some of our equipment, remotely command the mobile transporter to move down the rail, and get ready for the 4th EVA. The last EVA is really just a collection of several miscellaneous tasks. First of all, we're going to be installing 2 lights that will be used by future spacewalkers and robotics operators. And we'll be finalizing the load path so that only the 4 strut groups are carrying most of the structural loads from the trusses down to Destiny. We'll finish up deploying several smaller items up around the truss. And we'll be performing a general cleanup and photo documentation. And so let's roll EVA 4. Lee will exit Quest first this time, and Jerry will exit second and get on to Canadarm2. Jerry will be taking 2 lights with him, and he'll get a ride from the airlock under the laboratory Destiny to the port side, and he'll install a light onto the boom you see. And he'll take both boom and light back to the aft side of Unity, where he'll bolt it down and plug it in. And we'll remotely command this light on later. This is some older footage, and although the mock-up isn't a perfect representation of the light, it gives you some idea of the sizes that we're talking about. While Jerry's working on the light, Lee will be working to relieve the load path that's going through the center Destiny attach point near the claw. He'll just drive 3 bolts to loosen 3 cones that are still carrying some load. Jerry and Lee will then meet back up in this area on the port side to perform several tasks. You'll see in a moment the portable work platform. It's a set of 3 spacewalking tools that will give future spacewalkers a work area to stand in and attach tools and other items to. The piece on the bottom is called a tool stanchion, and we've decided to leave it in its launch location. The upper piece is part of a bracket that will hold large items, and we just stand it up. You can see it move. The third item is a foot restraint, and the next mission has asked us to move it to one of their work sites. So Lee will take it up to the P6 truss and leave it for the UF2 guys. While they're in the area, they're also going to be depressing 3 sensors on the flat truss base on the left side of the screen just to make sure they work. We'll also be removing a thermal blanket from this electrical box. The blanket is held on by long straps and a bolt. They'll just bundle it up as best they can and later bring it inside. This is the second such blanket that we've taken off of this type of component during the flight. These blankets were in place to keep the items underneath warm when S0 heater power to them wasn't turned on yet, but now they're not required. Next, Jerry will install his second light, this one on the front of Destiny. It mounts with a single bolt to the large umbilical tray that Rex put on Destiny during the first CVA. And from there, he'll be removing the energy absorbers from S0, shown flashing, and he'll mount them on either side of the mobile transporter. These are essentially large shock absorbers, and future spacewalkers will have hand-propelled carts to wheel down the truss rail. And these energy absorbers allow for attachment of these carts to the mobile transporter, and they also would cushion any collision between the cart and the transporter. So after this point, Lee will be working on the extravehicular charged particle directional spectrometer, and that's a mouthful. It's a device for detecting charged particles to aid in understanding the environment in which our astronauts live and work. It's pretty simple, actually. Lee will pull back a shroud, he'll loosen some launch bolts, and he'll push it until it stands up. Once in place, he'll be driving a single bolt to permanently stand it upright. And then he'll place the shroud back over the opening. And he's about to handle the bolt. After that, he'll be moving back towards the rat's nest, and he'll deploy a swing arm. This swing arm is just a small beam, has 3 connectors on it, and these connectors will later be connected to Unity. He'll release a single bolt, and then swing the beam into its open position. The future purpose of the beam is to provide a backbone for these cables so they aren't exposed to snagging by other spacewalkers. For now, we just open it and leave the cables in place. Meanwhile, Jerry will take a video survey to make sure some alignment marks are in good shape for later mating of the Canadarm2 base system, and he'll remove 4 covers from the holes where the base system's bolts will attach. Next, Jerry will install 5 handrails on S0. The long umbilical trays that mounted to Destiny were launched here, so he populates the spare area with handrails. He'll also take photo documentation of these 4 antennas, the GPS antennas, and these are global positioning system antennas for the space station. Throughout the EVA, and especially at the end, the crew will be taking several photos, and they just want to make sure that everyone understands the configuration that we left S0 and the space station in. And another late-breaking task associated with this particular EVA is the trace gas analyzer, and I'll just hold it up. This is a spectrometer which its purpose is to sniff out minute quantities of different types of gases. And so, for example, if we had an ammonia leak somewhere on the exterior station, we could use this device to sniff out where the leak was coming from. And this time we don't have a leak, let me just assure you of that, but we're going to take it outside and just see if it works, since it's been inside of space station for so long. So the crew is going to take it outside and expose it to vacuum and calibrate it. And then later they're going to use it in the airlock to see if they can detect very minute quantities of oxygen that may be leaking from the seals of the spacesuit or from an airlock panel, very, very minute leaks. And that's it for that EVA. And I'd like to mention that the 4th spacewalk is planned to take place on a historic day. It will be the 41st anniversary of Yuri Gagarin's first human space flight, and also the 21st anniversary of the first shuttle mission, STS-1. And after this last spacewalk, the crews will perform just a few remaining activities, and after shuttle undocking, the expedition crew will soon start getting ready for the arrival of the UF2 crew. The shuttle crew will return after having loosened and tightened approximately 250 volts, and after having mated or demated about 110 electrical connectors. And they will have certainly done their part in building our International Space Station, leaving 2 major elements ready to support further assembly. That's all I have.
Okay, now we'll start begin taking questions here in the Johnson Space Center.
Mark Caroth from the Houston Chronicle, and I guess I wanted to go back to the previous mission again when they had the difficulty with the spacesuit and the internal water leak. Did that pose any sort of issue for preparations on this mission that you know of at this point? And do you know what happened basically with that equipment?
Yeah, I'm familiar with that particular failure, and it was actually associated with the shuttle airlock. And for our particular mission, the component in the shuttle airlock which caused the water leak in the spacesuit is new, and it won't pose a problem on this mission.
Okay, thank you. And I'll admit I got confused on the 2 arms and how they help the spacewalkers. It sounded like on some, and maybe I'm wrong about this, but on some of the spacewalks they're using 1 arm, and on some of them they're using the other, but I may have been wrong about that. Can you kind of straighten that up a little bit?
Sure. On EVAs 1, 2, and 4, the prime arm that the spacewalkers will be using as a work platform will be Canadarm2, which is the space station robotic arm. And then on EVA 3, for about 80% of the spacewalk, we'll be using the Shuttle robotic manipulator for our work platform. That's because we're working on the cabling for the other arm. And at the very end, the very tail end of that spacewalk, we're planning to use the station arm again. During the first, second, and fourth spacewalks, when we're using the space station robotic arm, the Shuttle arm will be used as well, but it'll be used just for viewing.
Marcia Dunn, Associated Press. How long do you think each of these walks will last? Not how much time you've got allotted, but how much time you think the work will take?
Well, we've allotted about 6 hours and 30 minutes for each of the spacewalks, and I'd say that it's a pretty good guess that each one of them will take 6 hours and 30 minutes.
Could Carl Waltz or Dan Bursch just step in if necessary to replace one of the 4 shuttle men if they had to?
Well, the way we envisioned it was that each of the shuttle crew members sort of backs up the other shuttle crew members, and so if we had somebody get sick, it's likely that a shuttle crew member would step in and take the place as opposed to the station crew member. But I will tell you that Carl and Dan do have quite a bit of experience, and of course they did the EVA on February 20th. So we wouldn't be opposed to that, but their efficiency may not be as good as the shuttle crew members who've been training it most recently in the pool.
Okay, and I'm curious why Steve Smith is the lead spacewalker when you've got Jerry Ross on board. How was that decided?
Well, both Jerry and Steve are extremely experienced, and Jerry does have more hours than Steve. Honestly, it's an astronaut office decision that I didn't have any hand in at all. I can tell you that Jerry has a lot of experience going to space station and also to Mir, and so he's playing a valuable role as a transfer guy. And it might just be a matter of crew time allocation, who can be working the most with the payload and who can be working on other items. If you don't mind, ask the crew when they come up to the next press conference.
David Santucci with CNN. Compared to previous ISS spacewalks, how aggressive is this and in terms of tasks and the amount of time spent out?
Well, you know, each and every assembly mission seems to be building on each of the previous, so it's difficult to compare. I'd say that a lot of these tasks are kind of generic tasks, you know, driving a bolt, removing a blanket, and that type of thing. But in terms of overall criticality and towards the next space station mission and survival of the element, that sort of thing, this is a pretty complex mission. I'd say that it's equally complex towards other previous missions before this.
Okay, that's it for here. I believe there are questions at the Kennedy Space Center. We'll continue with those.
Hi, this is Steve Seislaw from Florida Today. I was wondering about the risk maneuver, the contingency risk maneuver in case it locks up. Is that something that, well, how many hours have you practiced that? Is that something you would do with a pistol grip tool, or would you do it by hand or a ratchet, or what?
Well, I sort of anticipated this question, so I have 2 graphics that I can show you. The first one here, you can see the space station robotic arm is the top upper arm, and it's holding S0. And we're pretending here the scenario is that we have some sort of failure which causes our EV crew member to have to go out and get on the shuttle arm, which is just below that, and drive that wrist roll. So you can see the operations there. And if we'll go to the next photo, this is the interface that we would be driving on the wrist roll if we had to manually perform this operation. And there's a lever just out of the picture here in the upper right-hand corner, which allow us to take the rolls out of motor and put it into an EVA drive. And then we would just use a power tool on this bolt that you see in the center here to manually drive the wrist roll to the location that it's required.
Okay, thank you. Sorry, thanks. Also, is Ella Nichilla or whoever's operating the station arm going to have a direct view of the work they're doing when they're at the S0, or is it going to be totally by monitor?
It's going to be by monitor. She'll be inside the space station while she's operating it. The shuttle crew members will have a great view looking out the shuttle's overhead windows, and they'll be able to see pretty much the entire length of S0, the forward face anyway. But Ellen will be operating off of monitors.
This is Phil Chen, Earth News. If I can get you to think back a month ago to the Quest EVA by Carl and Dan, what were the issues with the cables that they had left out that you originally were going to disconnect? Are they of any concern anymore? Any thoughts about the fact that you're glad now that you had that EVA, so that you did have the stinking problem then, and so now you're aware of it and prepared for it now, rather than if you didn't have that EVA and now suddenly this be a surprise? And any issues as far as the airlock depressurization time anymore?
Okay, well, first of all, let me say that I am very glad that we did that particular spacewalk. We learned a lot about the airlock quest and also the cable problem that you're talking about. The problem is not actually with the cables. What we did was we mated some cables that we call the launched activation cables to create the circuit through the lab to test out the electrical boxes in the lab that are used to power up S0. And so we made the cables, and we were able to verify that the circuit was working, but we had a hard time commanding with those two boxes. And so we left those cables mated, which was not the original plan. In doing so, it gave us a lot more time to figure out what the problem was and fix all the problems that needed to be fixed so that S0 can be activated on time on this flight. And it doesn't really affect our operations very much on this flight either. We're just going to demate the cables and get them out of the way. So yeah, it was. We're glad that we were able to test those boxes out before 8A and figure out our commanding situation. In terms of the depress, yeah, the depress that we did on the last EVA was just as predicted, and it took somewhere between 50 minutes and an hour. So it was just as we predicted. But since then, we've been thinking a lot more about the depress and how we'd like to do it. And with our 4 spacewalks on this flight, we're going to be doing several operations associated with depress, which are different than we did previously. First of all, on the last EVA, we used the depress pump. This is that Russian pump that sucks the air out of the airlock and puts it into the node. We used that pump down to about 1.5 psi in the airlock, from 14.7 all the way down to 1.5 psi. And we also used a valve starting at 2 psi. This valve is on the hatch. This is the known very slow depress valve that we have. And this particular time that we've decided what we're going to do is use the depress pump down to 5 psi instead. And at that point, we'll be operating what's called a vacuum access jumper. And this is a hose that mates on one side to the airlock and on the other side to a lab vent to vent overboard. And so the crew will route this long cable and hook up both ends of it, and then start the depress using a valve, and be using that from 5 psi down to 0, along with the hatch valve that's also slow. And we're predicting that we'll save about 10 or 15 minutes of overall depress time by doing this particular operation. So we're also doing, between EVA 3 and 4, we'll be trying to modify that valve. We're flying a new tool. It's a flat plate with sort of protrusions on it, which allows to remove a cap and pull out several screens, 40-plus screens that are inside. They serve a muffler function that we decided wasn't required, and they might be the cause of the reason why the depress valve is operating so slowly. So we'll be working with a number of options on this flight to still continue to try to improve our depress method.
EVA, do you expect to be able to depress in a normal period of time with all of these things you're taking?
I'm sorry, I didn't hear you very well.
You said that between EVA 3 and 4, you'll be doing the diagnosis. Obviously, that would have to be pressurized inside. But for the last EVA, do you expect to be able to do the normal depress, or will the slow valve still be the issue?
Well, we're going to continue to use the vacuum access jumper on the 4th EVA, but we'll also use this newly modified valve in parallel with it, and hopefully get some information about how much more quickly this is going to help us depress.
in your description. So why are you putting out the airlock spur so late rather than put it out on the first EVA, and then you can use it for the rest of the EVAs on this mission, where it seems like it would save you a lot of time?
Well, this crew is trained quite extensively on the path that's required in order to get up to S0 and do so without the airlock spur, because they need to do that on the first couple of EVAs, since the airlock spur is a lot lower in the priority list than, for example, hooking up the launch activation critical type of cables and deploying all the structures that are required to hold S0 down to destiny. So because it's a lot lower priority, that's why it's fallen into the third spacewalk, and also because our crew really very well knows the translation path that they want to use in order to get up to S0 otherwise.
And what size EMUs does everybody wear? You said that Rex had one already on the space station. I believe there's also a couple of additional ones. And if somebody does a grunt spell, what do you have as far as backup suit options?
Okay. Well, there's going to be a total of 6 spacesuits up there. And so let's see if I can get everybody. The one that's up there right now that we're going to use that's Rex's is actually Dan Bursch's, and that's a size medium. And then Jerry is wearing a large, sort of older style spacesuit. And then Steve and Lee are both wearing extra large spacesuits in the newer style. And so the fact that we have 6 spacesuits on board, without going through each one of them, I can assure you that they each have a backup way of going through a spacewalk in a different sized spacesuit.
Hello, this is Craig Cavalt with Aviation Week. As you look across the tasks as a whole across all 4 EVAs, what are the most challenging aspects to the?
Well, I'd say in the first EVA, our most challenging task is going to be working in the rat's nest area. That particular area, like I said, is kind of like being a large pressure suit and getting into a small car. It's just really confined space, and getting your gloved hand into to reach a lot of the connections is going to be a challenge. And in EVA 2, our biggest challenge is going to be deploying the aft strut. We've certainly worked out a really good method of deploying these large tripods, but it does require a lot of coordination. So I characterize those 2 as our most challenging tasks.
Okay, thanks. And along the same line, in the whole world of EVA, if you look at what you have to do with the airlock, as you just explained, the fact this will be the first time you're on the station arm, the diversity of tasks, and the fact the hardware is seeing space for the first time, is this set of EVAs really more difficult, more challenging than the Hubble mission of just a month ago?
Yes, well, the Hubble EVAs were extremely challenging. They had a kind of a different perspective on things. The Hubble interfaces are a lot more intricate, and a lot of the Hubble tasks were, they sort of were long tasks that were required to be done in one single spacewalk. And so in some ways we get the relief of having a lot of smaller tasks that can sort of fold into the next EVA if we don't complete them. In terms of just the magnitude of what we're doing and the criticality towards space station assembly, I think it is a big challenge, but in terms of each and every spacewalk being more difficult or less difficult than Hubble, I'd rather not characterize it.
Okay, thanks.
And this is Phil Chen again. The impression I get from you is that the Shuttle RMS is not going to be used on this mission, with the exception of when it's used as a cherry picker on EVA 3 and as the camera platform on EVA 4?
The camera platform also on EVAs 1 and 2. So camera platform EVAs 1, 2, and 4, and then on EVA 3 we're actually standing on the shuttle's arm.
And what happens if there's a problem with releasing the claw? How much tension, furlongs per square fortnight or whatever, does the claw put onto the S0 to lab interface? Is there any issue if for some reason you can't release it?
Okay, well, We do need to release the claw at some point to relieve the structural loading, but it's nothing that is time critical overnight. Needs to get done at that point. So we would, however, likely reduce the tension at that interface by relieving a beam that the claw is actually holding in order to lessen the loads that's in there. We actually have a backup interface to do that. So, but again, it's not extremely urgent, but we would likely in this flight use the backup method to release that tension.
Now we'll come back to Houston for any follow-up questions.
Marcia Dunn, Associated Press with 3. Who would be the spacewalker to do the manual override for the wrist joint if that became necessary?
Steve Smith and Rex Walheim would go out on that particular spacewalk to perform it. So Steve Smith would be the one on the arm actuating it.
Okay, thank you. And why? What went into the reasoning to have a spacewalk, a day off, 2 back-to-back day off? I mean, is this just a matter of giving the crew enough rest time, or is there something else going on here that you've structured it like this?
Well, originally it was 4 back-to-back EVAs, and through negotiations with the shuttle program and extending our stay and trying to be smart about planning the crew's overall timeline when there's a space station, we've managed to slip 2 days in there to give them a break. And we chose to do it like that based on the criticality of the task and things that needed to get done between the EVAs. For example, on spacewalk number 1, where we really want to activate S0 and supply heater power to both it and the mobile transporter. If we were to run long on that particular spacewalk, then we would be able to give the crew, maybe allow them to sleep in a little bit the next day. So that's why some of the days off were chosen like they were.
Thanks. And the lights that are going to be, the 2 lights that are being put on, do you have any way to say how powerful these lights are or how much area they're going to be able to illuminate?
I really don't. I'm sorry. I can probably get you a wattage, and then I do have it somewhere. I've got a picture which kind of shows you how it illuminates the station. So just walk up to me afterwards.
Good afternoon and welcome to the STS-110 pre-flight crew briefing for the upcoming mission to the International Space Station. Today we'll have introductions and a brief discussion of activities that the crew will do on orbit and then turn to questions and answers. I'd like to begin by introducing the commander of the mission, U.S. Air Force Lieutenant Colonel Mike Bloomfield. He comes to us from Lake Fenton, Michigan, and is a graduate of the U.S. Air Force Academy and has a graduate degree from Old Dominion University. He's a long-term Air Force test pilot and came to NASA in 1995 and is a veteran of 2 missions aboard the Shuttle. The first mission was STS-86 in 1997 to the Space Station Mir as the pilot, and STS-97 in 2000 to the International Space Station was his second mission. And with that, I'd like to turn it over to Mike for the rest of the introductions.
Thanks a lot. Before we get started, I want to give a big thanks on behalf of the crew. Flying in space is truly a team sport. It takes a tremendous amount of effort and a tremendous amount of dedication to successfully pull off one of these missions. When I came here to NASA 7 years ago, I was very impressed with how hard everybody works, with the intelligence that's out there, with the dedication that everybody has to getting the mission done. And over the last year, that's just been reaffirmed as we've gone from being assigned to the flight to having a final game plan in place to go out to the International Space Station and attach S0 to the top of the International Space Station. So on behalf of the crew, from the bottom of our hearts, we want to thank every member of the STS-110 team and the 8A team. A quick summary of our flight is the primary goal of our flight is to rendezvous and dock with the International Space Station and then successfully attach S0 truss to the top of the International Space Station. S0 is about 40 feet long, weighs in just under 30,000 pounds. And it's going to become the cornerstone for the big truss segment that you see on all the pictures of the International Space Station. Once S0 is attached, over the next couple of years, we'll continue to add trusses outboard until eventually we're able to add the solar arrays, which dominate the picture of the International Space Station that you see from space. And so we're the beginning of that. We're the first flight to go up and do that. To make that happen, we'll take S0 up in the payload bay of the shuttle. And then using the robotic arm on the station, we'll take S0 out of the payload bay and we'll attach it to a claw that sits on top of the lab of the International Space Station. And then we're going to perform 4 EVAs over the next 6 days to attach the struts that hold SRO in place, and then to do all the electrical umbilicals that will allow the power to flow from those solar arrays that will be out on the end of the truss back into the International Space Station so that we can power the labs to do the experiments that we want to do on station. That's a big picture overview of what we're going to do on our flight. April has traditionally always been a good month to fly in space. Yuri Gagarin became the first human to fly in space in April. The Space Shuttle first flew in space in April, and we have a first on our flight as well. Jerry Ross will become the first human to fly in space 7 times. What I'd like to do is just spend a little bit of time talking about Jerry, if I could. Jerry is a retired colonel from the United States Air Force. He's a proud graduate of Purdue University. He became an astronaut in 1980 before the shuttle even flew. Jerry was down here as part of the astronaut program. His 7 flights have included lab flights, satellite deploys, a visit to Mir, and 2 visits. This will be a second visit to the International Space Station. After the flight, he will have completed 9 spacewalks, more than any other American astronaut. And he will have logged almost 4% of his time in space will actually have been outside in an EMU. So he likes to spend a lot of time outside. For us personally on the flight, having had the opportunity to work with Jerry and to be with Jerry has just been a tremendous pleasure. You would not know that Jerry has been at NASA for 20 years by spending time with him because of all the excitement and exuberance and just plain fun times he brings to the crew. He's always has a smile on his face. He's always saying, I can't believe they're paying me to do this. And he just brings a continuous excitement to the crew. So we are very lucky to have been able to be a part of Jerry's crew and to enjoy this time with him. There's also going to be some other firsts on the flight. Steve Frick, Rex Walheim, and Lee Morin will fly in space for the first time. They will be the 412th, 413th, and 414th humans to fly in space. They will be the 260th, 261st, and 262nd Americans to fly in space. We haven't quite figured out how they're going to determine who gets which slot, but we'll let them work that out. I can't verify it, but I believe this will be the first time 2 grandfathers will perform a spacewalk together. On EVAs 2 and 4, Jerry and Lee will go outside and they will perform the spacewalks. Both of them are grandfathers. Steve Smith likes to refer to them as the silver team for obvious reasons. This is going to be the first time that we will perform back-to-back spacewalks from the International Space Station airlock Quest, and we'll do that between EVAs 2 and 3. This is going to be the first time that the EVAs will be controlled from the International Space Station control room rather than from the shuttle side. This will be the first time that the station's robotic arm will be used to move the spacewalkers around during the spacewalks. Previously, the arm has been used to move the airlock around, and we're going to use it to remove S0 from the back of the payload bay and put it on top of the lab. But then Ellen Ochoa will be spending a lot of time moving the spacewalkers around during the various spacewalks so that they can accomplish their tasks more quickly. And finally, this will be the first time that we will fly actually a digital television system on board the orbiter. So we'll be able to link down digital television images from what we're doing up on orbit. Before I move on and introduce the rest of the team, I want to acknowledge 3 folks that aren't able to be with us here today, and that would be Dan, Carl, and Yuri. They're up on the International Space Station right now. They've been up there for 100 days as of Monday. And they've been working very, very hard to get ready for our arrival and get ready for this pretty intense 6 or 7 days that we're attached to the International Space Station. They're going through a lot of prep work in the airlock. We were able to talk to them on Monday while we were down at the Cape at TCDT and tagged up on the EVAs. And I sent them a note afterwards, tell them, hey, thanks for the conversation. We had a good time talking to you guys. And, oh, by the way, TCDT is going very well. And I got an email back from them the next day, and they had actually taken a picture of the Kennedy Space Center while we were down there with their digital camera, and they had downlinked it to us. So it was pretty cool. But they've worked incredibly hard to get ready for the flight. What I would like to do today, now moving on to the rest of the crew and giving everybody an opportunity to talk, is I've asked each member of the crew to relate a personal side of the flight to you. You've all had an opportunity to listen to Bob Castle and Jeff Hanley and Dina and all the other folks that have been wrapped up with the flight describe what the mission is in good technical detail. So I'd like to try and bring you a little bit of the positive side, or the personal side of the flight. And to do that, I've asked each crew member to relate a personal side of this flight to you so that you can understand what we're thinking as we're going through this flight. For me personally, there's two tasks that I am really looking forward to and that I spend a lot of time practicing for. The first one is the rendezvous of the shuttle with the International Space Station. I have spent numerous hours in sims trying to learn the best way to do that. I have talked to a lot of people that have flown it. I've watched people from MCC fly it, and now this will be an actual opportunity for me to fly the shuttle up and to dock with the International Space Station. And for me, that's going to be one of the highlights. And then the second part that I'm looking forward to is something I've practiced now for 7 years, and that is to land the shuttle. And we have a shuttle training aircraft that we fly out at El Paso and down at Kennedy Space Center. And I've done it a lot, practice over 1,000, so I'm looking forward to actually being able to land the shuttle. And so with that, I'd like to introduce Commander Steve Frick from the United States Navy. This will be Steve's first flight in space, but we have dumped a lot of stuff on Steve. Steve is a 1986 graduate of the United States Naval Academy. He's an F-18 naval aviator who has some time in the Gulf War, fighting that war, and he's wrapped up on everything on the flight. His primary job, obviously, is the shuttle systems and the orbiter systems, and making sure they're all up to speed. And he's an integral part of the rendezvous, as I'm going to rely on him heavily to make sure that I don't make any mistakes. And before I make an input, I'm going to check with Steve and see if he agrees that that's the way I should go. When we do the undock, Steve is going to perform that, and he's going to do a fly around of the station so we can take a bunch of pictures and document what the shuttle or what the station looks like after we leave. He's also going to be the one that's going to be doing the robotic arm operation on the shuttle side. That was, for the most part, it supports what's going on the station side, but on EVA 3, he is actually going to have one of the EVAers on the arm, and Steve will be doing all of the robotic arm movement from the shuttle. The biggest challenge that Steve has had on this flight, I think, though, has been setting up the video system and the camera system to support what Ellen's doing on the station robotic arm. The station robotic arm is a real challenge to operate and to work, and Ellen is actually doing it from inside the lab, and there's no windows on the lab that allow Ellen to look outside and see where the arm is moving. So she's very dependent upon all the camera views that we can give her so that she does not take the arm and run it into anything up there. Those camera views come from Steve's hard work. He has put together an incredible video system that's going to allow Ellen to see all the different views and make sure that she has the clearance to safely operate the arm. And so without further ado, Commander Steve Frick.
Thanks, Mike. I think the things, Mike talked a little bit about what I'm responsible for in the flight. I think when I think about it, distilling it down, my job along with Mike and with Ellen and with Rex on it is to get the orbiter safely into ascent, and then with Lee on entry to get it safely home. And to back Mike up on his rendezvous, though, from the sims we've done, I don't think we're going to need much work there. He drives it in every time right on the money, so that'll be interesting. But once we get up on orbit, my job really, we talked a little bit about the arm ops, but it's mostly going to be just to back up the mission specialists who are doing all the hard work when we're up on orbit. We got 4 guys that are doing the spacewalks, and Mike talked about Jerry and his 9 spacewalks. Well, Steve's going to be, what, 7th spacewalk, I guess. So we'll have the number 1 and number 2 experienced American spacewalkers. And it's been interesting for me as a new guy. Everything about training for a mission is new, but watching how those guys get ready for a spacewalk has been one of the most interesting things for me, because I had no idea what went into the preparations to do what they're going to do with the S0 Trust. It's going to be really remarkable to watch that from my reasonably unique position inside the orbiter. Mike talked about how I'm sending all the pictures over to Ellen, but I get to see everything too, so I'll have a good view of what's going on. I have to make sure Ellen gets what she needs to move the arm, and hopefully if I don't do too badly, she won't be having to call me every minute and say, zoom this camera in or move this camera over. Hopefully I'll try to stay ahead of it just a little bit, and do a little arm ops, moving Steve around on the arm on EVA 3, which I'm looking forward to. But other than that, just taking a lot of pictures and making sure everyone has what they need so that they can get their job done when we're attached to the space station, which is really our mission. I'm certainly looking forward to flying the orbiter for undocking. We've done a lot of simulations, but I don't think I'll be able to really predict what it's going to feel like to fly this thing, which weighs over 200,000 pounds at that point, off of the station, fly around well enough for us to get all the pictures we need to document what the station looks like, and then move it safely away so we can get ready for landing. I think just the general space experience is going to be something, but I'm looking forward to hopefully doing a good enough job so that these guys can do their part and get everything done. Rex Walheim, MS1, and I are going to be working together a lot on Ascent. Rex and I are really responsible for all the systems on my side of the vehicle, the engines, the hydraulics, the electrics, and that's been, it's a lot of work to get ready for that, and Rex has had to do that in addition to training for all of the EVA tasks, which is really his primary job. This isn't his first time in Houston. He was lucky enough to go from the winter in North Dakota for his first task in the Air Force down to summer in Houston as a flight controller in mechanical systems back in the late 80s. And then off to Edwards to go through a test pilot school where he was actually the top flight engineer in his class, in his test pilot school class, and worked at Edwards for a while before coming down here with Lee and myself. We've been training since '96 and are looking forward to our chance to go up into space. Rex?
I think the things I'm most looking forward to, obviously the EVAs are going to be a tremendous challenge and exciting time. But we've had the opportunity over the last year to listen to the veterans who've flown before and to find out what they're looking forward to. And I think one of the things I'm looking forward to after talking to Jerry and the others is after a long, hard day of work, going up to the flight deck and just taking a few moments to watch the world go by. I'm a window seat kind of guy. When I get the choice between a window seat and an aisle seat on an airliner, I always love to take the window seat. And I like to look out the window so much that on the long trips I have trouble sleeping because I think, well, look what's coming up next. We may go over the Rocky Mountains or whatever. And it's the best when you get one of those maps that show you where you're going to be. And you're thinking, well, I can't go to sleep now. I'm going to fly over Greenland. Well, on the space shuttle, we have one of those maps too. And so we'll be able to see what's coming up. And so it might be a little bit hard to go to sleep at night thinking about all the neat things you could be seeing. So I'm looking forward to that, and especially also seeing if we get a chance to see the Northern Lights. When I was stationed in North Dakota, like Steve talked about, I used to have a chance at the end of a second shift to go out in a farmer's field somewhere when it's very dark and watch the Northern Lights come over, and it was just spectacular. And so hopefully we'll have a chance sometime on this flight to see either the Northern or the Southern Lights, and I think that would just be thrilling. Now to my right is Dr. Ellen Ochoa. Ellen is a fellow Californian like myself. She went to her undergraduate work at San Diego State, where she majored in physics. And then she went to Stanford University. Now, Stanford University happens to be the arch rival of the school that I went to, the University of California at Berkeley. So given the opportunity to introduce somebody from Stanford, usually I would have a few comments to make about their educational background. But you have to remember, though, that Ellen is the space station mechanical arm driver. And on my first spacewalk, I'm going to be riding on the end of that arm. So as Ellen's maneuvering me around some very large and hard objects, I better not make any snide comments or I may have the sense snapped into me pretty quickly, so I'll be careful there. But Ellen is our flight engineer on Ascent, and so she basically keeps the whole flight crew on the same page of the checklist and working the procedures and has the big picture, and she's done an outstanding job at that. She's flown in space 3 times already, and we've tremendously used her experience. And as I said before, she'll be the robotics operator, and she's one of the best robotics operators in the world. Ellen?
Thanks. This flight is generally billed as an EVA flight, which makes sense given the 4 hard EVAs coming up. But I tend to think of it as a robotics flight, and it really is a test of the station robotic arm. It's only the 2nd time we're using this arm to lift a large payload out of the bay, and this one, the S0 truss, weighs twice what the airlock weighed, so it will be quite a bit different task than moving the airlock around. And as Bloomer mentioned, it is the first time we're using the arm to move spacewalkers around. And at various times during the spacewalks, we put the arm in all different kinds of configurations wrapped around the zenith side and the nadir side of the lab, and often with really tight clearances. So it's really a team effort to carry out all the robotics tasks. And I have a great team to work with. Obviously, I work with the Expedition 4 crew members, Dan Bursch and Carl Waltz. They're both also station arm operators, and all 3 of us will be using the arm during this flight. Dan will be the one that actually installs S0 on top of the lab, and Dan, Carl, and I will all be operating the arm during the EVAs. And then Steve Frick and Bloomer, as we mentioned, are really providing all the camera views that we need to do those tasks. And it may sound like a simple task, but actually it's a fairly complicated system to get all the camera views that we need from the shuttle side of the whole complex over to the station side where we need them, and we've worked that plan pretty hard. But really all the robotics operations are dependent on getting those views. And then, of course, the 4 other MSs on this flight will all be on the arm at some point during the EVAs, and they'll be providing clearances to me or Dan or Carl, whoever's operating the arm. And the other spacewalker who's outside as well will help with calling clearances, and we intend to use them probably especially at night when it may be hard to interpret the camera views. And then we have a whole team on the ground. We have the robotic flight controllers who are watching our every move and helping make sure that we're moving the arm exactly the way that we've planned to and that we need to do. And we've also had a great team of procedure developers and engineers who have put together a great plan for us to use the arm on this flight. So working with that whole team is really, to me, the highlight of this flight. And now I get to introduce our MS3, which is fun because you've probably never met anybody like Lee Morin. He has an impressive number of degrees. He has a bachelor's, 2 masters, an MD, a PhD, and has done residencies in surgery and aerospace medicine. He has an array of Navy certifications as a diving medical officer, undersea medical officer, submarine medical officer, and as a flight surgeon. He's been involved in special ops in Desert Storm. He's done jungle guerrilla warfare training. I think he's done samurai training. In civilian life, he had a private practice in occupational medicine. He had his own TV show. He was a guest on Good Morning America, where he demonstrated a device that he developed, which translates medical questions and answers into over 100 languages. And at the moment, he's building a supercomputer at home, so when he gets back from this flight, he can work on some plasma physics problems. But in addition, he's getting ready for his first space flight, and on this flight, he'll be going outside on 2 spacewalks, and he'll be involved in completing the final structural attachment of S0 to the space station, which is one of the critical milestones of this flight. Not surprisingly, he's also one of our crew medical officers, and he's in charge of our onboard laptop computer network, so that should keep him busy. Well, I had to leave out a whole lot, in the interest of time, but usually.
Thank you, Ellen. When I first came to NASA over 5 years ago, shortly after we got here, while we were having our astronaut candidate training, we were given technical assignments. And our technical assignments allow us to work with a NASA team and get involved with actually working on some of the problems that maybe later we'd get a chance to fly as astronauts. And my very first technical assignment was to work on the portable computer system, which is in fact the cockpit of the space station. The cockpit of the space station is not a cockpit like you think about it, where you're in a little room with lots of switches and knobs. It's actually a bunch of laptop computers. And the laptop computer is how you control and operate the systems of the space station. And that was my technical assignment, and I was privileged to be able to do a lot of work on that PCS system and was very involved in the development. And now 5 years later, I'm going to get a chance to use that on orbit, and that will be how I'll send the command standing or floating, I guess, next to Ellen in the U.S. Destiny lab. As she moves the S0 into place, I'll be able to send that command, which will close the claw that Mike mentioned, that will first grapple and hold the S0 onto the lab, and then immediately Steve and Rex will go outside EVA and start bolting it on. And then I'll be able to follow that up, going out with Jerry, who was, and Steve on the inside telling us what to do, and I'll be in the palm of Ellen's hand on the end of that robot arm, putting all that training together. So that's really an unbelievable situation to be in at this point, and I think that's what I'm looking forward to, those milestones. Next, I want to say just a word about Jerry. You already heard his bio, which is very impressive, and Jerry was one of our instructors in EVA training, both Rex and myself, when we went through the Advanced EVA Skills program that led us to us being here on this mission. And Jerry and Steve were both instructors, And to now be their proteges on our first flights and our first EVAs is really a privilege. So that I'll turn it over to Jerry.
Thank you, Lee. Well, after you heard Ellen's introduction of Lee, I'm not only the most senior member of the Silver team, but also the most underachieving member of the team. I've really enjoyed the time with the entire crew, and I've told people before that the two things that really make a mission for me are the challenge of the mission itself, but at least equally important to that is the crew members that you get to go fly with. And I certainly couldn't ask for a better team to go fly with. It's been a lot of fun during training, and I know that we're all anticipating this mission very much, and I'm looking forward to being up there with them in Sherman in the events. In addition to the EVAs that Lee and I will be conducting, and I'll be supporting as the IV support crew member to get Rex and Steve suited up before they go out on their spacewalks, I'm also been charged with the responsibilities for developing the plans for the post-insertion time frame of the flight, as well as the preparations for coming home. And also kind of the cargo master, helping with all the transfer of the hardware from the station back to the orbiter to come home, as well as what we're bringing up to resupply the crew with. I guess if I were to tell you the number of things I'm anticipating or looking forward to on this mission, it would probably take several days. I know what to expect, and I can't wait to do it again. I think I must be addicted to space flight because I love every aspect of it. I love the training I get to do with very talented, very dedicated individuals here on the ground, as well as the folks at the Cape and elsewhere that prepare the vehicles and the hardware that we're taking into space, and spend so much time and detail in doing that. But obviously, I'm looking very much forward to the launch. The launch is an incredible experience, something that you basically cannot put into words other than to just smile and think about it a lot. I'm also looking forward to getting up there and seeing our three friends up at the International Space Station. They've been up there for over 100 days now, and I can only imagine what it would be like to be isolated up there for 100 days and not have any other people to talk to. So I'm looking forward to, sharing some experience with them and hoping that they can enjoy that time together before we depart. I'm also looking to, obviously, getting outside on some additional spacewalks. 1985 with my buddy Woody Spring, after we'd conducted some experiments of assembly of structures in space, I not so kiddingly quipped to him, well, Woody, let's go build a space station. And I was fortunate enough to be involved on ISS-2A, where we started the assembly of the station, and now this team kicks off the third and final phase of the station assembly, where we get to start laying down the railroad track that will be allowing us to build the structures further out along the truss. I guess one other thing that I might be looking forward to is watching the three new guys on this crew, as through their eyes they get to experience what an incredible thing it is to be in orbit and to see God's beautiful creation of Earth, this very fragile satellite that we all live on, from a totally different perspective than they've ever been able to enjoy before. And I guess one final thing that I'd be looking for on this flight and beyond this flight, quite frankly, is the completion of the assembly of the International Space Station and the fruition of the types of research that we all hope will be conducted up there, and the types of benefits that will be coming back down to every human being here on the surface of the Earth. With those words then, I'd like to introduce my good buddy over here on my right. Steve Smith is the other Stanford graduate on this crew. Right, Rex?
That's right.
Okay, just checking. Steve's an incredibly talented guy. This will be his fourth flight. And he'll be conducting his 6th and 7th spacewalks on this mission if everything goes according to plan. Steve is a former payload officer here at Johnson Space Center, as I earlier in my career. Also has been serving as the Deputy Chief of the Astronaut Office for several years before he became assigned to this crew. Steve's primary role in life on this flight are the EVAs. He's our lead EVA crew person, and I think he's done a masterful job in pulling these 4 EVAs together. They're very challenging. And going to be a real beat-the-clock type of process to try to make sure we get every one of the demanding tasks done in a timely fashion. Steve?
Okay, thank you, Jerry. As Jerry mentioned, it's going to be really special to see 3 people fly for the first time. For me, one of the best parts of flying in space is riding a rocket. It really is an incredible experience, and I have thought through my mind many times what I'm going to do at MECO, and my plan is to go look at each of those 3 in space, right in the face, and see how much they enjoyed that ride. It's going to be really something very special to see that. Also, for me, it's going to be the first time going to an orbital outpost where people are living, so I'm very excited to see what a world-class research facility looks like that people are actually living in. By coincidence, one of the people up there, Dan Bursch, was a mentor for me, as well as Tom Jones was, on my first flight, so it's really neat for me to see Dan in space after having him been up there for 3 months. And also, of course, for me, one of the highlights of the mission will be doing the spacewalks. I'm very interested to see how they compare to a Hubble spacewalk, which is what I've done before. It's been very interesting to see the parallels and differences in training, and I'm anxious to see what it's going to be like in space doing a spacewalk on the space station versus doing one on Hubble. In addition, the spacewalks and the robotics work were not really done as far ahead as they were on other flights. We were named very late in the game. As you may recall, years ago, the crews from 2A through 7A, the first major assembly flights, were assigned 2 to 3 years in advance of their flights. We were named in March of last year, so we've had just about a year to get ready. So it'll be interesting to see how the robotic and EVA tasks go on a major assembly flight with only having worked on them for about 1 year. So that will be interesting to see also. As we said, too, the other crew members have worked here in Houston before in the operations community. I also come from that family. It's been very interesting to go from the operations and development family over to the crew side. But one thing that I have found very rewarding about this business is working with an incredible group of people. We were in Florida 2 days ago looking at the S0 truss, and I was checking the different work sites that I will be responsible for working on an S0. And in particular, I looked at one bolt that I wanted to make sure I could access with the power tool, and I was looking at that bolt, and I realized then at that point how many people had been responsible for getting us to where we were. Someone had to design that bolt. Someone had to decide what material to use, how many threads to have on it, how thick to make it, how many of those bolts to use to hold this certain piece of equipment to the S0 truss. Someone had to design the power tool that we're using to remove that bolt. Someone had to teach us how to use that tool. Someone had to design the spacesuit we're wearing to perform the spacewalks, and of course someone had to teach us how to use those spacesuits. So you can see that the team grows more and more as you think about how we do each task, and really we're at the end of that chain. We're the ones that are actually turning the bolt, and to have this incredible team having prepared the hardware and the crew has been incredibly rewarding to us to work with that team. So it's going to be really a pleasure to have a successful flight and reflect on all their great accomplishments preparing us and the hardware. With that, I guess I'll turn it back to Doug or Mike.
Yeah, and with that, I'd like to turn to Q&A. But even before that, I'd like to mention that we have received reports from Moscow that the Progress 7 resupply vehicle has been launched from Baikonur at 2:13 Central Time today, Central Time U.S., and it has successfully achieved orbit, and its solar arrays and antenna have been deployed successfully. So that's great. With that, questions here in Houston. Mark.
Mark Carew from the Houston Chronicle. I have a couple of questions, and the first is for Mike Bloomfield. You sort of discussed can you discuss how tightly choreographed your flight is and how much flexibility you have to catch up if something falls behind early in the flight? Do you have the possibility of an extension day? Are you really working within an 11-day time frame?
Well, right now, on our timeline, we do have a +1 day. So we have enough consumables on board to get 1 extra day. And that 1 extra day is built in there for contingencies. So that gives us a little bit of slop. Our busiest day by far is Flight Day 4. And Flight Day 4 is the day after we rendezvous, and it's the day of the first EVA. And S0 has a timeline on it. It has a lifetime. Once we take it out of the payload bay, it's got a 16-hour clock, and once that 16 hours expires, then the possibility exists that we could do damage to S0 because it got too cold. And so that's the clock that we're running against, where we have to get power on it. And that Flight Day 4 begins by taking S0 out of the payload bay and then using the LCA, the claw that's on the top of the lab, to hold it in place, and then we send out the first EVA team with Steve and Rex to attach the power and the struts. We have built into the plan in what we call bingo times. And for EVA 1, as we go down and we have certain things that we're going to do, like we're going to attach some struts and we're going to attach electrical connectors. And if we start getting behind, then we have a second set of cables up there called LTA cables, which is launched to activate. And it's basically a way to bypass the normal way of hooking up S0 and give us power to the critical boxes just for a short amount of time. And so that will, not for a short amount of time, for an indefinite amount of time, but it's not using the main power source. If we do hook up those LTAs, then we're going to have to disconnect them at a later point and hook up the real cables. And so we're trying to go down the path of getting the reel cables on first, and then if that doesn't work, if we find ourselves falling behind, then we can go ahead and hook up these LTAs, and that will buy us some time. That day is extremely long. Right now it's planned out at 14 hours, which, to put things in perspective, it takes us longer to get out the airlock on the station than it does on the shuttle. And on Hubble, if you recall, they had the one day where they found the water in the spacesuit, and they had to go back and reconfigure everything. That's kind of where we're starting on all of our EVAs out of the airlock, because we're starting basically at that point. We've talked about it in great detail about what we're going to do. We've got the bingo times built in, and we got the extra day. And some of the stuff that's towards the end of the flight on EVA 4 is a lot of get-ahead tasks. Things that we don't necessarily have to do. They're kind of helping out the next crews that are coming up. But we can slide some of the stuffs off of EVAs 1 and 2 into EVAs 3 and 4 if we need to. So there is some flexibility, but from an overall big picture, you're right, Mark. That's the big concern on the flight, is the length of the days that we have when we're going out of the station airlock.
Okay, thank you very much. And I had a question for Dr. Ochoa. The problems with the robot arm on the station came up sort of late in the game, and I'm really not clear how much this threw kind of a curveball in for you and your other colleagues that use the robot arm, but could you give kind of a sense of what you've had to do to scramble to cope with this, or is this really not that much of a problem for you guys?
Well, in looking at what our backup plan would be if the good string, the redundant string, should go down during our flight, one of the sort of ground rules was to try to minimize any retraining of the crew, either me or Dan or Carl on orbit. And so the folks on the ground here, the robotics flight controllers and procedure developers, did a really great job of coming up with a new trajectory that we will use during the flight. This is our new nominal trajectory for getting S0 out of the payload bay and installed, which changes what we do as little as possible. And while all the joint angles for the positions are different, a lot of what we do with the hand control, all the manual flying, is essentially the same. And the main change is that we've changed sort of the middle part of the maneuver, which used to be sort of an auto maneuver that was just going to move S0 sort of forward and around the corner, getting it kind of set up for the install, which is flown manually. We've taken that out, and we've replaced that with a series of single joint maneuvers. And the whole goal of that was to try to reduce moving the wrist roll joint whenever we could, to move it as little as possible, and also to always be in a position where if the good string failed and we had to go over to the string where we can't use the wrist roll, that there's only one time when the EVA crew members would need to come out and actually manually move that joint, and then we could still go ahead and manually install S0 on the lab with the arm. And in fact, if it fails in the second half of this maneuver, we wouldn't even need the EVA guys at all. We have a plan in place to go ahead and use the prime string without the wrist roll and be able to get S0 onto the lab. So in fact, it's required a little bit of training, but not nearly as much as we thought at first when we were first finding out about the problem and trying to think about what some of the options would be.
All right, next, Marcia.
Marcia Dunn, Associated Press, probably for Commander Bloomfield. In talking with the space station crew, have they put in any orders? They've been up there a long time. You're going to be the first people they see. What are you taking up for them as presents or food or what have you?
Well, they missed the rodeo here in Houston while they were up on station. So our game plan is to have a country western themed dinner one night while we're up there. I know Carl is a big country western fan, and he likes to go to the rodeo. So that's kind of one of the things we want to do between the first and the second EVA. Jerry, do you think of other requests that they've had?
We are taking up some fresh clothing for them. Most of the other things are fairly ordinary kinds of things. Some new black notebooks to keep their notes and diaries in. More gray tape. You can't fly in space without Velcro and tape. And some parts for some things that broke. We're going to give them a replacement tray for a printer, for instance, from our hardware once we're done with the mission.
Okay, thank you. And I guess for either Steve or Jerry, how is it, Steve, that you became the lead spacewalker on this flight when you're sitting next to the most experienced American spacewalker? How did this all come to be?
Well, when Commander Bloomfield started assigning us to our different jobs, he had the most experienced human ever to fly in space that brought a set of experiences that were this big. And then he had me, and my experience was more about this big. So he took what I knew how to do and then have expanded Jerry's role significantly, especially when you have 3 new people on board. I think Jerry's influence has been incredible on them, and it seems like every training session we go to, I know Mike and Alan and I will hear something Jerry says, and between the 3 of us, we have, what, about 8 space flights worth of experience. We look at each other and say, we never even heard that before, so it's proved to be really valuable to us.
Okay, with that, I think we'll move to the Kennedy Space Center. I understand we have about 7 sets of questions there.
This is Phil Chen, Earth News for WPGH in Pittsburgh, Pennsylvania. So obviously it's for Steve Frick. Tell us about growing up in Pittsburgh, a wonderful city. I got a lot of friends from there, and what it was like and getting interested in the space program. Any early childhood influences, any hobbies, sports, other things that you liked as a kid?
Well, I kind of view Pittsburgh and Pennsylvania as being God's country, so it was hard to leave. But I have too many good memories of Pittsburgh to even begin to mention. I grew up in the Steeler era of Super Bowls, so it's been hard to move away from that. But I mean, I remember as far as things that got me excited about space, I remember getting up in the middle of the night to watch moon landings when I was growing up, and that probably started the idea of what it would be like to be an astronaut. I was also very interested in flying, so I spent a lot of time growing up learning about flying and learning about Navy ships and getting interested in that, and so that's why I ended up going to the Naval Academy. But I've always had a warm place in my heart for Pittsburgh and Pennsylvania, and have enjoyed going back. I still have an older brother, Ted, and his family who live there, and I get to go back and hopefully see a Steelers game and a Penguins game every now and again.
And for Mike Bloomfield, same question for WXYZ in Detroit, to replace Pittsburgh with Lake Fenton.
Well, I'm from Lake Fenton, Michigan. Obviously my hometown, and my parents still live there. My brother Dave lives just down the road in Linden, Michigan. And it's always good to go back home. I went through elementary school there, junior high and high school, and it was a small community. We graduated about 150 in my high school class, and so it's one of those communities where everybody knows everybody, and you could never get away with anything because my mom knew all the other moms in town, and the word would always get back to them. But the whole community, and I think we'll all attest to this, as you grow up, everybody you come in contact with has an influence on your life in some way, somehow. I can think of the football coaches that had a big influence on my life growing up, and the baseball coaches. And there was, you had the special math teacher, English teacher that took the time to point you in the right direction. And the way I look at it is I'm taking a part of each one of them up with me in space when we go up, because they influenced my life and they pointed me in a direction some way. So it's a real honor for me to be able to fly in space, knowing a little bit of everybody from Lake Fenton is going with me.
This is Steve Seislaw from Florida Today. Mike, I'm wondering about again with the wrist joint. If you had your druthers, would you rather wait until that arm and joint was working perfectly to make this mission, given how time stressed you are?
Well, we've looked at it very close, and we have a plan in place. As Owen described, we still have a full-up spring up there on the arm, and so although there was a small change to the trajectory for S0 for getting it out of the payload bay and getting it on top of the lab, everything else right now has not changed. So we need another failure yet to get us into the backup mode, and even once we go to the backup mode with the wrist joint frozen, we can still do the entire task. Steve and the entire EVA team have come up with plans that will allow them to do the EVAs even without that robotic arm. And it may take longer, and we may not get all of the tasks done on all 4 EVAs that we are planning to get done right now, but we'll get all the critical tasks done. We've broken down each of the tasks and each of the elements, like for example attaching the struts or attaching the cables. They all have a category of importance assigned to them, And we believe, and I agree, that we have a plan to get those important tasks done, to get S-Serial attached, get the struts on it, get the cables attached, and then be able to move the mobile transporter back and forth. So that will be define the success of the mission. And we have one more NBL run, the Neutral Buoyancy Lab run, that's going to go tomorrow and on Monday. And Steve and Jerry and the rest of the EVA guys will take a look at those plans without the arm to make sure that we can get there. We've spent the last couple of weeks in the VR lab, the virtual reality lab that we have here, looking at positions to do the various tasks. And so we won't be as efficient. I'm not going to kid you, we won't be as efficient if we end up in that mode where the arm ends up with the wrist joint locked, but we still have the ability to get the job done. So.
Thank you. And for Jerry, you have your the second space tourist coming up soon after this mission ends. And what I'm wondering is, you're the first one to fly 7 times, but in the future, that record could be held by many people who aren't necessarily professional astronauts. How do you feel about that prospect?
I hope so, Steve. We aren't doing our job right if we limit the number of times that people can go fly in space. What we're trying to do is find a routine and safe way to do it and find reasons to go do it. And I'm hoping that my granddaughters will have a chance to go fly in space many times, and I'm hoping they'll take me with them.
This is Peter King from CBS News Radio, and for Jerry, seeing that we've had a number of sports analogies used during this newser, you'll forgive me for this one, but you're about to become really the Henry Aaron of space, breaking what's been a 4-way tie for the number of space flights. And I was not aware of the EVA record you're about to set. I'm just wondering your feelings on that, and your feelings on the 3 men that you've held that space flight record with, most notably John Young, who was the first to fly 6 times.
John Young is my hero. There's nobody that will ever surpass what John Young has been able to achieve in his lifetime as an astronaut. I don't care how many times anybody ever flies in space, they won't be able to outdo what he's done because of when he did them and how he did them. I really feel very blessed to have had the opportunity to serve my country in such an incredible way. I came here as an Air Force officer to work and was fortunate enough to be selected into the astronaut office. I've had incredible opportunities to work with talented people both inside the astronaut office and outside. And I've had the good fortune to be selected for quite a few missions. And every mission has been unique, very challenging, and very satisfying. And I think this one's going to be at least one of the best, if not the best, in terms of who I'm flying with and what the challenges of the mission are. So I think, again, it's just been a very strong blessing. And I think the Lord above has been taking care of me all through this. And it's hard to understand how I've been able to be so fortunate to do this, but I can tell you that I certainly have appreciated every minute of it.
And for Commander Bloomfield, at the risk of embarrassing Jerry, there are a lot of people who've not flown who are waiting to fly in the astronaut corps, yet Jerry Ross gets to fly 7 times. You've already mentioned some of his attributes as a crew member, but what are the things that you think really makes him stand out from the rest, and the things that really got him into space 7 times?
Well, I mentioned early on that Jerry loves to fly in space, and he's good at it. He is really good at it. Jerry has the unique ability to take a situation when it comes to working with hardware and trying to operate it, being able to look at that piece of hardware and almost immediately know whether or not the hardware will work, and if it won't work, what needs to be done to make it work. And so that's one thing he has. The second thing that Jerry has is he has a tremendous amount of energy. He can tell you stories of some of the hardware that he designed for EVAs that needed to be fit checked at the Cape. And he would spend just a tremendous amount of energy getting down to the Cape, checking the hardware, bringing it back to JSC, checking it against some of the stuff back here at JSC, and running back and forth to make sure that the hardware works. So between his mechanical ability to look at hardware and see if it works, and his tremendous energy, he's a huge asset to the office. And you got to admit, you've heard this before, but the flights are getting more and more difficult. And I'll be frank with you, I don't know if ours is the most difficult yet, but it's right up there as far as everything that we have to do and all the firsts that we have to do. And Jerry, if you're going to do that, you want your first-class team on it, and that's why Jerry's assigned to this flight, is he has the ability to look at all that stuff and make it happen. I had to make a decision early on what to do with Jerry because he has so many talents, and the success of this flight is going to be determined a lot by how well the rookies do, not putting any pressure on them because they're well trained and they're going to do a great job. But you needed to take somebody, and I told Jerry this early on, is I wanted him to take all the rookies on this flight and put them under his arm and try and infuse those 6 flights of experience that he has into each one of their brains before we go, so that when we get up there, we're ahead of the game. Jerry mentioned also that he is doing the post insertion right after we get up in orbit. He's responsible for putting the plan together to turn the orbiter in from a rocket ship to the spaceship that we're going to use while we're up on orbit. And we sat down and looked at the plan early on, and we actually changed it in a couple of places. It wasn't as efficient as Jerry wanted, but what it did allow is it allowed Jerry the opportunity to spend time with each of the new guys so that they would learn how to operate in space. And Jerry is a real blessing to have on the flight. He has had a huge influence on how we do business, and he's done that because of his ability to work with mechanical things and his tremendous energy.
This is Jerry Hannafin, Time Magazine, and this one is for Ellen. And may I say, I'm UC Berkeley, but I'm a neutral reporter. And how long did it take you to develop a degree of proficiency and precision using, without outside reference, using only camera references, handling that arm?
Well, I probably had a chance to start on that on my last flight, STS-96, where I flew the shuttle arm. And even though we did have a little bit of an outside view, most of the work that we did, and again, it was having a crew member ride around on the end of the arm for an EVA, was out of the view of any window. And so that was really my first experience. On my first 2 flights, I was deploying and retrieving payloads with the arm, which you could generally easily see out the window. So in 96, that was really my first experience of using a robotic arm and depending primarily on camera views. So this was kind of the next step up, where now you really don't have any window view at all, and you're doing quite a bit more tasks, because really for the 3 EVAs, we're operating the arm during the whole EVA, as well as the S0 install. So we just kind of moved up a level for that. And one of the things that we've done is there's, in general, 3 monitors in the robotic workstation on board the Destiny Laboratory that we can put camera views on, and we have the capability through the internal video system of sending 2 shuttle camera views over. And so you can use 1 monitor for one of the station robotic arm cameras and then 2 for shuttle camera views. In a lot of cases, that really didn't seem adequate for the tasks that we were trying to do, because the arm was in such a configuration, there may be 2 or 3 different places on the arm that were close to structure simultaneously, and no 1 or 2 camera views could really allow you to monitor all that at once. So we decided pretty early on to take a couple of other monitors and just run cables directly from the shuttle internal into the station ourselves. And so I actually now have 5 monitors to watch at one time, which in most cases I think is going to give me the camera views that I'll need to do all the tasks.
This is Craig Tavalt with Aviation Week. Hey, Jerry, why don't you take a minute and wax eloquently on, given all the things that have to be done to make EVAs go well, the maturity of the entire system that it takes to do EVAs, how that's progressed up to the ability to do something like you guys are about to do.
Well, it's only taken us about 20 years. Literally, when I got here, we hadn't even intended to do any spacewalks out of the space shuttle. It was only planned to be an emergency or contingency capability. The attitude that was being expressed when I got here was EVAs are one failure away from certain death, and you're not going to do them unless you absolutely have to. And we went from that mentality to where now a lot of things are planned to only be able to be done via EVAs or spacewalks. And I think that we're probably hit a pretty happy medium on what we ought to be able to do with spacewalks and what we ought to have done robotically or remotely. It takes a lot of intuition, it takes a lot of ingenuity, it takes a lot of hard work on a lot of people's parts to try things and see what works and what doesn't. I think you saw during the period after Challenger and until we started flying the assembly flights that we started to build up a very robust capability both in the astronaut office as well as in the engineering design teams and in the flight control teams and training teams. We had lost almost all of that expertise base in the wake of the Challenger accident, so it took us quite a while to build that back up. And we fought very hard to put in place a plan that allowed us to start designing the types of hardware that we thought were going to be needed to support the very challenging spacewalks that we're in the middle of now. We needed to have EVA teams that had some experience under the belt, so we started developing a series of planned missions. Some of them were very non-impact in terms of what had to be manifested on a mission, basically just putting some crew members out there and giving them some experience of what it's like to be in zero gravity in a spacesuit. And then we started to manufacture some of these tools that we had thought about and had done some testing on in the water tank and put those tools on board the orbiter, and then we started sending crews outside to demonstrate how well those tools would work. And again, continuing to build up the level of expertise both here on the ground in terms of the training and the flight control teams as well as the crew members going outside. I think one of the other very, very important things that we had to do was to add a new training facility here. The neutral buoyancy laboratory that we have out at the Sonny Carter Training Facility was an absolute necessity. I don't know how we could have ever conceived to attempt to build the International Space Station without it. And it took 10 years basically from the time I flew on STS-61B until we finally had approval for that facility and then started to build it. And I think any of us would attest that without the experience that we've had out there and without the robotics tools that we have in place in the water as well, that I'm not sure how we would have ever done it. I think all those things combined is a very synopsized way of telling you that it takes a lot of hard work and a lot of dedication, and quite frankly a lot of money to make sure that things work right. But when you're investing in such a tremendous new research facility on orbit that we can use internationally for many years to come, and I hope will form the foundation for future international endeavors which will ultimately lead to individuals placing their feet on the surface of Mars. I think it's an important milestone, a very significant one, and also a very necessary one.
Okay, thanks a lot. And for Steve, you yourself here at the start raised the Hubble comparison on this flight. When you look at bringing in the station arm, the fact this hardware hasn't seen space before, the diversity of the tasks, is this comparable in difficulty to a Hubble EVA scenario as we had just in the last month, or perhaps even more difficult?
Well, I'd say that the answer is yes and no. Some of the tasks on this flight are easier because they're just turning bolts to attach mechanical pieces to other places, but in some cases it's harder because the places we go to are farther away from the space shuttle, for example, and we have to use now the space station arm. I guess some of the other interesting parallels and differences as we've trained, the first is that Hubble was in space for the last, I'd say about 10, 12, 14 spacewalkers that have gone to the Hubble Space Telescope never got to see it. It was already in space, so they really relied heavily on the mock-ups. One advantage we've had on this flight, of course, is that some of the space station is still on the ground, the piece that we're taking, so it was good to be able to spend time with the real piece of hardware. One of the other parallels or interesting comments about how we train is that the Hubble Space Telescope is an incredible spaceship. They really have paved the way for all the EVAs we've done the last 5 or 10 years in terms of hardware development, and tool development, and training, etc. But it is a project that is located at the Goddard Space Flight Center, and that way is very consolidated, whereas the space station project is worldwide. So sometimes getting some of the technical issues resolved or things changed has been a little bit more of a challenge. But in the end, I think we're benefiting from a lot of the road work that Hubble has done for us. It'll be interesting to meet again in a month to see if that has turned out to be true.
This is Jim Banky at Space.com. I guess a question for the commander and related to the security. Coming to TCDT here and not being greeted by us, I guess you can do without the media, but is there any impacts on either training or looking forward to launch, even issues with your families coming here in terms of what you can and can't tell them about your flight or when you're launching, or access to the Cape and being able to do the traditional pre-flight family stuff?
Well, as far as the terminal countdown test demonstration at the KSC, we were able to meet with the media momentarily. Just before we left, we gave a statement there as we got ready to head back. The schedule at TCDT was a little bit different this time because of the way they were doing the hardware. They had to do some hardware changes, and so the dates changed. Normally you go down on a Monday and they have the actual liftoff the practice liftoff is on Wednesday or Thursday, and this time we actually had to go down on Sunday. And then the timing didn't work out too well because we finished up yesterday, and so we would have had the conference yesterday and then turn around and have one again today. So I'm not sure the security is the reason for the not having the press conference down there. The security at the Cape is good. We had an opportunity to sit down with Jim Halsell, who's down there right now as an astronaut working at the Cape, and he spent an hour with us going over what the security plan is, and we all walked away from that feeling very good that they've done their homework and they have a plan in place. It has had an impact on the guests. As you know, before September 11th, we were able to take cars out to the NASA Causeway, and since then they don't allow any cars out there, so that does have an impact on our guests. For the most part, our families, our immediate family that is, there's very little impact on what they're going to be allowed to see and their timetable while they're down at the Cape. I don't know if we'll ever go back to the way it was. I mean, I've heard the phrase, you know, we're in a new normal era now after 9/11, and we're quite frankly very thankful that there's a lot of folks down there looking at the security and making sure it's all in place. So we're confident they've got a game plan and that it will be well executed. Well, we're really happy to be down here to the Cape. A trip into space always begins down here at the Kennedy Space Center, and there's a great group of people down here that build spaceships that allow people to go into space, and we're very fortunate to be part of that team that's going to go into space. We got a real challenging mission ahead of us. As you know, we're going to go to the International Space Station, and we'll meet up with Dan and Carl and Yuri, who've been up there for 100 days now. And then we're going to go ahead and continue building the International Space Station by adding the first truss segment to the top of the International Space Station. Well, once we get up there and we dock to the International Space Station, we'll reach into the payload bay with the robotic arm on the station, and we'll pull that truss out and we'll stick it on top of the lab. And then we got 4 EVAs planned. A group of 4 folks will go up, or 2 folks at a time, to 4 EVAs and attach all the struts and the electrical connections. And then we'll also have the opportunity to move the mobile transporter, the railroad car that's up on top of the truss, back and forth a couple of times. So we're looking forward to the flight. We want to say thanks to all the folks down here at Kennedy Space Center that make space travel a reality, make dreams come true. And with that, I'm going to turn it over to each member of the crew. Thanks.
I'm Steve Frick. I'm the PLT. It's my first chance to launch in the space shuttle. Something that's interesting to me is the fact that we're the first flight of all Block 2 space shuttle main engines. And I had a chance to work with the folks that were developing them, and I'm real excited to launch with that. The guys at Pratt & Whitney at West Palm Beach, and the guys in Rocketdyne out at Canoga Park, and the Stennis Space Center and Marshall, and here at the Cape gave us some great equipment. I'm looking forward to getting a chance to ride those to orbit.
My name is Rex Walheim, and I'm Mission Specialist 1. And I wanted to extend my thanks to all the people at the Johnson Space Center. It literally takes thousands of people there to get us ready for flight, starting out with our trainers, and we really have a lot of training teams. For instance, for the people who train us to fly these jets here at Ellington, to the people who down at the Neutral Buoyancy Lab who teach us how to dive and work the spacewalks, to our shuttle trainers, the people who teach us how to fly the shuttle and learn the systems, the stations trainers, and all the various other programs we go through. And then we also have a myriad of flight controllers there who get the mission all laid out, what we got to do, and then we go out and execute it, and they work very hard. And there's also lots of other people at Johnson Space Center, like the engineering staff, the people who work all those problems that crop up at the last minute and find out what's safe and what needs to be replaced. And then all the other engineers and specialists, from the medical staff to our administration specialists, our secretaries who arrange everything for us, to all the other people there. And so I wanted to extend my thanks to them.
I'm Ellen Ochoa. I'm the MS2. I'll be operating the station robotic arm on flight along with Dan Bursch and Carl Waltz, Expedition 4 crew members. This is an exciting flight for the station arm. It's only the second time we're using it to lift a big piece of equipment out of the payload bay. We're using it to unberth and install the S0 truss. And it's the first time we're going to be using it to move spacewalkers around. So during the EVAs, we'll be using it extensively to take all the other mission specialists on this flight for rides to various different work sites. And it's fun to work the robotic arm in part because it's really a team effort. Dan, Carl, and I will all be working together. We work with Steve Frick and Bloomer on the shuttle flight deck, who are shipping us all the camera views. All the rest of the members of the crew, as the spacewalkers, will be telling us where to go to get them to the best work sites. And that's just the onboard team. We have a great team on the ground as well, which consists of a lot of the robotics workers at Johnson Space Center, the flight controllers, the trainers, the engineers, and also a great group of folks at the Canadian Space Agency who really know the details of the robotic arm. And even in the face of a failure that we had a month ago, they've gotten us ready for flight. We have a great plan, and we're real excited.
I'm Lee Morin. I'm Mission Specialist number 3, and I'm going to be privileged to participate in some EVAs to put that S0 on top of the lab. I'd like to take this time to thank, on behalf of the entire crew, to thank our families who made it possible for us to be here today, and to also thank all of our teachers and professors at our schools and universities who prepared us and got us ready so the NASA team could train us for this wonderful day coming up. Thank you.
Hi, I'm Jerry Ross, MS number 4. Very excited as an entire team here to be taking S0 into space. I personally have been involved in S0 development and testing for several years now. And on behalf of the entire crew, I'd like to thank the S0 team that has worked tireless hours to get the vehicle, get the hardware ready to go fly. Steve Hoffman and all of his Boeing engineers and technicians, Tip Talone and his NASA group that has made sure that everything's come together and has been tested out properly, and our own astronaut office personal man on the spot, Kevin Fott. We're looking forward to a very exciting day on Thursday. Thanks.
Hello, I'm Mission Specialist number 5, Steve Smith. One of the highlights of this mission, and one of the many highlights, will be 4 spacewalks we'll perform right in the middle of the mission over a 6-day period. And the 4 spacewalkers on this flight feel very well prepared and very well supported by the folks across the country who prepared us for this. We have folks who have developed and delivered the tools, the same with the suits, our space suits. We've also been trained very well by the folks in Houston. and also supported by the project office there, the EVA project office there. So on behalf of the spacewalking team, we wanted to thank all those groups who have prepared us for these 4 spacewalks. Many thanks.
Stay right there. Do a group shot. Good morning and welcome to our launch minus 2 days countdown status briefing for mission STS-110. We have as our briefers this morning Jeff Spaulding, NASA Test Director, Ben Jimenez, the STS-110 Payload Mission Manager, and Kathy Winters, our Shuttle Weather Officer. And we'll begin our briefing today with statements from each of these, beginning with Jeff.
Thank you, Bruce. Good morning. I'm pleased to be here this morning to report that the STS-110 launch countdown has begun and things are proceeding very well. The Shuttle Atlantis is in excellent shape as we continue our preparations for Thursday's launch to deliver the S0 thrust to the International Space Station. We've obviously been fairly busy the last couple of months readying the vehicle for launch, including adding a significant number of modifications, about 24 in total throughout that flow. This does include the first flight of several items on the vehicle that I just wanted to mention quickly here. The Block 2 engine cluster, this is the first time that we will be flying all 3 Block 2 engines. And as you may recall, those engines, as opposed to the Block 2A, give us quite a bit more safety margin. This, as I mentioned, this will be the first flight of all 3 of those together in one cluster. We did also add modular memory units, which are black boxes, to the vehicle this time. There's 2 of those in place, which essentially consolidate 5 previous boxes that were used for recording and mass memory storage. So there is a significant weight savings up in the crew module and also some better efficiency associated with those new modular memory units. The countdown, as I mentioned, is going very well. We do have a couple of non-standard type items that we'll be working later today. In Escape, which is our safety ensemble that we use to perform certain tasks. Over the weekend, we did discover some residuals left in one of our solid rocket booster hydraulic power units in an overboard drain line, some residual fuel in there. We did go ahead and clean that up over the weekend. When we go in to configure that area for launch today, we're going to do that in Escape. So that's the only thing non-standard about that is the fact that we'll be in a higher class of safety ensemble for that operation. And that's just to be sure that the folks that are going to be out there would be safe if there's anything still in those lines. We don't expect that there would be. In addition, last night we did discover a small leak in a 2.5-inch oxidizer return line on the 95-foot level of the fixed service structure. We are going to, immediately after the first escape operation that I just mentioned, we are going to go and perform a second op that will remove that 2.5-inch return line and then cap off both ends of that line. And then we won't need that line any longer during the remainder of the countdown. As far as significant events from now through launch, of course, we'll be loading the onboard cryogenic tanks. And then later on, of course, we'll also be performing checkout of the ground communications network and verifying all of the onboard systems with the vehicle as well, prior to getting into our rotating service structure retract, and then, of course, EP load leading up to Thursday's launch. Our launch period is 4 hours in length and extends from 2 o'clock on Thursday afternoon to 6 o'clock, with our actual launch time occurring within that window. The mission will be an 11-day mission with 2 weather days. Our landing will be on the afternoon of April the 15th. As far as our scrub turnaround plans and capabilities go, we do have 4 days of hold time for our liquid hydrogen and 6 days for liquid oxygen. We do have 24 and 48-hour turnaround capabilities as our normal plan, which could give us a maximum of 4 launch attempts in 5 days based on that. The range is fairly open, and we don't anticipate any near-term issues associated with the range that would preclude us from launching. The launch time for this particular one does give us the ability to at least evaluate whether we would look at 3 in a row, and that, of course, would be based on a lot of other criteria that we have to evaluate as well. But the launch time is favorable for at least taking a look at that for this particular one if needed, and if weather or some other circumstance dictated that that was something we wanted to take a look at. So in summary, our processing team has done an exceptional job during the flow from the time it has rolled into the OPF to the time we've been at the launch pad. The vehicle is ready to go. All of our flight and ground systems look great, and we're looking forward to Thursday's launch.
Okay, thanks a lot, Jeff. And now with an update on our payloads, Ben Jimenez.
Thank you, Bruce, and thank you, Jeff. As Bruce has mentioned, I'm the payload manager for KNC here. What I really am, though, is a representative of thousands of folks throughout this country that have made the space station payload and the utilization payloads successful so far, and will get us on orbit and make it a success on orbit. With that, I'd like to take the opportunity to at least recognize a handful of folks who have done a tremendous job for space station and for utilization. First and foremost is my counterpart, Steve Hoffman, his supporting crew of Steve Riola, Eric Hansen, and George Vincent, and of course my supporting crew of Barbara Calvert, Rita Del Santo, Laura Bales, Joe DeLai, and George Hamilton, and specifically for utilization, Johnny Mathis. For utilization, let me talk about the mid-deck payloads that we have. We have a number of those flying on this STS-110, and I believe they are all located in, or at least identified in your press kits. First of which is the Biomass Production System, or BPS, the Biotechnology Refrigerator, or BTR, the Commercial Generic Bioprocessing Apparatus, or CGBA, the Commercial Protein Crystal Growth High Density Experiment, CPCGH, the Protein Crystal Growth Enhanced Gaseous Nitrogen Experiment, PCG-EGN, the Zeolite Crystal Growth Sample Stowage, the ZCG, and the Arctic Freezer. For the payloads I just mentioned, we have a late stowage of 24-hour installation for the PCG, the ZCG, the CGBA, and the CPCGH. And at L-19 hours, the BPS will be installed. The other payload I mentioned, the BTR, that is going in today as we speak. For scrub turnaround requirements of the payloads, all that I mentioned are 48-hour requirements, with the exception of the CPCGH, which is a 96-hour requirement. On the main payload in the payload bay, S0, I'm sure you know all these statistics, but I'll repeat them for you. The payload is 44 feet long, approximately 15 feet wide, and weighs just a little under 27,000 pounds. The S0 itself arrived here at KSC on June 11th of 1999. We have been assembling and testing the S0 truss since then. Throughout its assembly and testing period, we did perform what we called a multi-element integrated test through the period of September 30th, 2000, ending on June 25th of 2001. A significant milestone reached for S0 is what we call our post-software load initialization test. That is where we loaded the flight software that is flying on S0 for the mission, and we activated S0 as it would be activated on orbit. And that was a very successful test for us. We took the payload to the pad on the 23rd of this month. We installed it into the orbiter on the 27th, and we closed the payload bay doors last night about 8 o'clock. All is well with S0. Let me talk a little bit about the mobile transporter. The mobile transporter arrived as a separate unit from S0 back on July 15th of 1999. Its first translation on the rails of S0 was conducted on the February 15th, 2000. It went through the multi-element integrated test beginning with September 30th, and that test also required it to translate up the rails. We did remove the MT from the truss back on July 10th of 2000, and that was to facilitate our continued assembly and testing operations for S0, and we installed the mobile transporter for flight on January 18th of this year.
Okay, Ben, thank you very much. And now for an update on our weather, Kathy Winters.
Good morning. Currently we do have looking at the satellite picture, we do have a jet maximum that's moving through the Gulf of Mexico. That's kicking up some thunderstorms out there. We are expecting this early this evening to see some thunderstorm activity associated with that, as well as our sea breeze interaction that we get here in Florida. Tomorrow afternoon, we also are very moist, and we do expect to see, again, thunderstorms in the afternoon. For our tanking forecast, we start to see the effects of a front that's moving into Florida, and we do have expect a chance of some thunderstorms and showers in the area, most likely to the north of our area during this time, but we did put in a 10% chance of violating constraints for tanking due to those thunderstorms. Then for our launch forecast, that front should be pushed to the south and over the Lake Okeechobee area. We do expect there's some moisture behind that front, so we do expect to see some isolated rain showers in the area, and also a chance to get a low ceiling at 2,000 feet. With this, we are going with a 30% chance of violating launch constraints. For the solid rocket booster recovery, The front is well to the south of this area at this time, so I'm not really looking for any significant factors for them, only 5 to 6 feet of wave height. And then for the Kona sites for launch, we are looking at just scattered skies at white sands and no significant weather there, and then just a ceiling at 20,000 feet at Edwards. And for the TAL sites, also looking good for the Thursday launch. Just looking at scattered skies generally through each of the TAL sites, and no significant weather at that time also. For a 24-hour delay, the weather does start looking a little bit better for us here. Less chance of rain showers, or no chance of rain showers at that time, but we do expect to see some low clouds still with a chance for a 3,000-foot ceiling. That would give it, that's why we're putting in a 20% chance of violating launch constraints. And there is a concern at one of the Kona sites at Edwards with some winds, looking for a crosswind concern there with the 14 peak 24 knots. That location. And the TAL sites also have some concerns of mainly looking at Maroon for a ceiling at 4,000 feet and also a chance of showers. And also at Zaragoza looking for a chance of showers as well. And then if we do slip to a 48-hour time period, we still are looking for a chance for a 3,000-foot ceiling. Crosswinds become more of a concern at this time. Winds from the 050, 15 knots, peak 20. And we also are looking for some isolated coastal showers to come over the area as well. So we're looking for a 40% chance of violating our launch constraints. The Kona sites aren't showing any concerns there. We do have a ceiling at White Sands at 16,000 feet. But no major concerns. And then for the TAL site, 48 hours, we're looking for showers at Zaragoza, a chance for rain showers in that area. Also at Maroon, a ceiling of 4,000 feet with a chance of showers. And also at Ben Guerir, looking for a chance to get a ceiling at 2,000 feet. And this concludes my briefing.
Okay, Kathy, thank you very much. And let's open it up for questions. Let's start with Stephen, right here.
Steve, Siselaw, Florida today. My first question is for Jeff, and that is, what was your previous Block 2 experience? I know you flew, I forget which flight you had it on, but I mean, did it perform just as you expected? And do they get any more inspection because of being the new turbo pumps?
Actually, they get less inspection long-term because of the turbo pumps. That's one of the advantages of the better or more improved and advanced turbo pumps. They're a bit more robust as well, which allows us to perform the inspections that we currently perform every mission less frequently. We've used these particular ones, flying them individually on STS-104 and STS-105. We did not fly them on the last mission, and they performed very well. There was really no significant issues associated with the engines themselves, and we expect them to still perform in a particular manner.
Thanks. And for Ben, excuse me, given the ease with which everything has gone together to this point, how do you keep your people from getting a little complacent when you're putting up a structure that, in this case, is not pressurized, as complex as it is? I mean, how do you work your team around that issue?
Well, let me first answer that by saying if it was easy, we wouldn't be doing it here at NASA. And I wish it was easy to do, but it was not that easy. However, to keep the team active, we still have a lot of activities to do for the payload. We had a lot of shuttle integration work that needed to be done. While the payload flies up unpressurized and really unpowered, we are looking forward to seeing it on orbit, getting it up there, installing it on the lab, the Destiny. We had an opportunity to work with the astronauts. A lot of the EVA astronauts had asked us questions. So we're all excited in getting that payload launched this Thursday, and I don't believe I have any problem with getting the folks out of complacency, shall I say.
Okay, thanks. Marcia?
Marcia Dunn, Associated Press for Jeff. I'm wondering if you could just say whether or not the new security guidelines that you all are following for the countdown, including keeping the launch time secret, has that impacted the way the launch team has had to go about its business for this countdown?
No, there really hasn't been a change to any of the internal operations that we've seen here at Kennedy and even at the other centers as well. You did mention there's a difference in the control in some of the times that are discussed and released at this point, and we did just implement that for this particular mission, starting at this particular mission. However, we've had those plans in place to do that previously, and just based on the fact that information was made so readily available prior to that point, this seemed like the best point in which to put that into place. So, but as far as the impacts to the team, really hasn't been any at all. It's gone really well. The team's done everything in the same manner in which they always have, very professional, and we've had some challenges during this flow, as we always do, and they've responded as we expected every single time, and that's why we were in posture as we are today.
Have you had to have special meetings, at least just to talk over all this? What can be said, what can't be said, et cetera?
There's been some discussions with the folks, just to remind them of what the guidelines and policies are. But we've integrated those into our standard meetings and our standard discussions, so it really hasn't been outside of the normal routine that we do.
Thank you. Go ahead.
Roger Gilmet for Space.com. For the launch weather officer, when you're stating percentages of violation, is this a weighted average or something covering the entire launch period, or is this percentage go, no-go targeted at the specific preferred launch time?
We're generally looking at the launch window is what we're looking at, and also mainly what it says, if you say 40%, if there's 10 days that look similar, that's for those days, we'd be violating the launch constraints during that entire window and not be able to launch due to weather constraints. So that's how we work our percentages, but it is for the launch window.
Okay, Roger. Let's go to Mark back here.
I'm Mark Carreau from Houston Chronicle, and my question's for Scott. There's been a number of activities on the launch pad on the shuttle over the last week or so. I wonder if you could kind of run through the hardware inspections and repairs that you've accomplished before the countdown really started.
Sure, I'd be happy to. I think that was for me. That's all right. We have done quite a few of our normal, obviously the normal plans and procedures to get the vehicle ready to launch. We've been working those right along. We did take a late delivery of the payload, as we mentioned, and based on the timing of that, we've been working that right up here up to launch countdown. In addition, we've done a couple of other things, including we removed some connector savers out at the launch pad, which was some unplanned work based on an issue we discovered with one of them. And so these connector savers are simply adapters that go on an end of a connector prior to mate. And what it does effectively is it reduces the amount of wear and tear on the connectors on ones that are mated and demated quite regularly. We found an issue with one, and so in order to better understand, while we were trying to better understand that, we made a decision to go ahead and remove the rest of those that were of a concern to us and take those out. So I drove a little bit of extra retest once we had to demate some connectors that had already been previously mated. But that was done pretty much within all of the guidelines of the other work that we had to do as well, so that went along quite well. In addition, we did have some bolts that we discovered on an ohms pod fuel flange. There were 6 of those that we removed and replaced with some stronger bolts based on some testing that was done that we discovered at White Sands that these bolts may not be strong enough, so we went ahead and elected to remove and replace those as well. Previously in the flow, we did change out a couple of boxes, one of the modular memory units, and also one of our master events controllers we did remove and replace, but that was very early in the pad flow as well. Other than that, it's just been the normal amount of work. It's been a fairly, it hasn't been a very long pad flow. It's fairly compressed. It was about a 23-day pad flow. So it's been pretty busy right along with the normal amount of work as well.
Okay, thank you, and I'm sorry, Steve. And I had a question about to follow up on the unpowered, the S0 that goes up unpowered. I guess how's it powered on the launch pad, and there's no battery power or anything on the truss when it goes? Could you just explain that a little, how that works?
Sure, I can. The payload itself is unpowered, as I mentioned, until we get it on orbit. When we get it attached to the lab, using the avionics umbilicals, etc. There are no batteries that fly up with it. It does not contain that. It's essentially an unpowered payload when it goes into the payload bay, and until it gets installed onto the lab, we don't have any power going through the S0.
Okay, Bill?
Yeah, just a quick one for Kathy, just making real sure we're all on the same terms. You're talking launch window, 10-minute window as your weather is valid versus the 4-hour period.
Right, not the 4-hour period, the real window.
Okay. Another question? Steve? Okay.
First for Ben, when was the last time the mobile transporter was moved before y'all packed it up for launch?
Let's see, are you asking when it was translated up and down the rails? Let me think back on that and look at my notes here. I think that was back in late 2000 was when the last time we did it. When we removed it from the truss back in July 2001, we did not require it to be translated down the rails. What we did was we detached it from the truss. It was on its supported GSE rails, and we just manually pushed it off to the side, so we did not require translation of it.
And for Jeff, is there increased CAL site security, particularly in Morocco these days?
Our security posture has been pretty much about the same as it has been, and as far as any changes and differences, none that I'm aware of, and actually probably none that I'd be able to comment about even if I were them at this point.
Okay, Marcia?
Yeah, Marcia Dunn, Associated Press for Ben. Any last-minute additions for the space station crew, or anything that the Russians have brought over that they want to send up on the space station?
I'm not aware of any last-minute additions or any Russian items or hardware that have been added recently. No.
And when you're flying up the refrigerators and freezers, can you put any ice cream into the space station crew or any like food, or is this strictly experimental stuff?
It's strictly experimental items. The BTR, the biotechnology refrigerator, flies up, I believe, unpowered, and we take samples from the station, put it in the refrigerator, and we fly it back powered. So we do not bring up any ice cream for them.
Go ahead, Steve. Take one more.
Okay, a quick one. Steve Seislaff again, Florida Today. Jeff, I was wondering if the ARM test yesterday pretty much wipes out that issue for the FRR today.
And did you want to comment on that?
See, the ARM test, the only one I'm familiar with was on Friday when we tested the 6DOF patch. I believe that went very well. That does resolve the issue for the mission for S0. And I believe I had heard, and I'm not quite familiar with it yet, and I'll have to get back with you, that there was another issue that appeared during that test. It was separate from the original issue of the wrist roll joint, but my understanding is that we're working through that, and I don't have any further information on that.
And we'll actually be able to review that at our pre-launch news conference this afternoon at 4 o'clock.
Well, thanks. It's again good to be in Houston or Florida. Thank you very much. Maybe I should go back to Houston. It's good to be in Florida, which means that we're down here and getting ready to do another launch. It was just a week ago that we were here and we had a good flight readiness review. In that flight readiness review, we had a number of open items that needed a little bit more discussion and some time for the folks to do some more analysis. Today we met to discuss those topics, and except for one issue, we are ready to go. That one issue is the ET door power drive unit. And what we discussed today is that we just haven't had enough time to complete all of our studies. And the team would desired another 24 hours. We have some additional testing and inspection that we wanted to do, and we just ran out of time to get it done prior to today. So we gave them another 24 hours to get that done. And we have scheduled another meeting tomorrow afternoon, an L-1 meeting at 1600 local, to go through the results of their inspections. And I would characterize this as not unusual. It's just that from the time of flight readiness review being 1 week to the time of L-2, we just didn't have enough time to complete everything that we needed to do to get ready for launch. And having an extra 24 hours is good margin for us to go finish our inspections. So that's what's in front of us for STS-110. I would mention that we are still riding the crest of the wave of Hubble Space Telescope. It was such a fantastic mission. I don't think I've come down from cloud 9 on that mission yet, and here I am focusing on STS-110, which I will tell you is just as challenging and will be just as spectacular as the Hubble Space Telescope repair mission and servicing mission. This year, as you know, we have 5 more shuttle missions in the next 6 months, which promises to be an active spring and summer. We plan to deliver over 50 tons of hardware to the space station, and that starts with the S0 truss on STS-110. So we look forward to that and anticipate a lot of success for these missions. I should also mention that you know that we have 4 vehicles here in Florida. One that is getting prepared to go into a maintenance period, and then 3 others that are in different stages of being processed. And I think that is a good statement to make here in Florida and in this largely processing center. I think this is the right place to house our vehicles for the long term, and I think it's good that we have that, not only the processing being done here, but it's also good that we take the time to do our maintenance on OV-103 here also. I think this will open up a whole new opportunity for us to do our scheduling a little differently. Instead of taking vehicles out of service for long periods of time, I think we'll look at it differently and see if we have opportunities to schedule our maintenance and inspections instead of having them all at one time and being done in a block mode for 18 months to 2 years. We'll take the time here to use the processing workforce to do what's smart, do the inspections at the right time, and do modifications at the most efficient time. And I think there's lots of opportunities for us to be cost effective in the way we manage our vehicles. So I think it's a great improvement for us. And we're looking forward to it. And we're looking forward to STS-110 and starting again on assembling the station.
Thanks, Ron. And now we'll hear from Bill Gerstenmaier with the International Space Station Program.
Again, it's a pleasure to be here in Florida. As Ron said, at FRR we still had some open items on as far as space station goes, and that was with the Canadian arm up on board space station. The prime string, the wrist roll joint had a problem with it. It still has that problem. And at FRR we hadn't completed the software development and the software certification for that. That failure was detected on orbit March 5th or 6th. And it's pretty amazing to us that between March 5th and now, we've got that problem completely understood. We have a software patch delivered by the Canadians that effectively bypasses that joint on the arm, allows us to go do the S0 install with single fault redundancy in that system. So we're able to go ahead and install pretty much as we had planned before. The complexity of that is not relatively obvious to you, but if you take a look at what it took for us to put that software patch together, it was kind of unique. You know, we're going to mask out this one joint, or not use the one joint, the wrist joint, and we went to our simulators to try to simulate that. Well, it turns out our simulators can't accommodate that mode because the arm was never designed to operate with that joint not operating. So our engineers and teams in Houston had to figure out a way to work through the simulations to develop a way to get the new trajectory to position the truss with minimum wrist motion. So they found a position where they can manipulate the arm to one position that just requires one smooth motion of the wrist, and then you can take it from that position all the way to where it gets attached to space station. So again, they were able to take a situation that was never designed for, never thought of, analyzed it, figured out a way to get one position movement to move the wrist via EVA if required. The Canadians developed a software patch. It was fully certified, shipped to Houston, actually ran up on orbit on Friday. We ran in that mode on Friday and verified that the arm works just as the simulators on the ground said. The software's ready to go fly, and we're fully ready to go fly. We're also excited about starting to put the trusses up this year. You're going to see the S0 truss. We call it the Keystone. Some folks on the pressurized side, some of the lab people call it pig iron. We don't think of it that way. It's much more than that. There's about 450,000 parts that are reconciled on that truss. Everything goes in and out of that truss. Stuff goes to node 2, stuff will go to node 3. It interfaces to the lab, interfaces to the airlock, it interfaces to all the modules on station. So the complexity and the systems integration task associated with this truss is tremendous, and it's neat to see it all come together. It'll be exciting to watch the EVAs over the flight and see the truss get up there and truly be the keystone of Space Station.
Okay, thanks, Bill. And next we'll hear from Dave King from the Shuttle office.
It's good to be back. As Ron said, we have had quite a bit of work that's occurred on this vehicle, get it ready to go fly. We've had several technical issues to work through. We think we're there, and we're excited about being in this position. We're also, as Ron said, excited about the mod work that's come to Florida. We're preparing every day to be able to perform that work in a very efficient way, and we're glad that the work has come our way, and we think we're going to be able to accommodate that in a way that's going to be great for the program in the future. We did, as you well know, we did pick up the count last night. We're doing just fine. We're going to pick up with the PRSD load here in an hour or so, maybe a little bit down on the bar chart, but nothing significant. And we really don't have anything to talk about that's significant. We've got a few nits that we need to go work to get us there, but we're ready to go do that. And we've obviously been following the PDU technical issue for some time, and we think we'll bring that to resolution tomorrow, as Ron has said. And with that, we're ready to go.
Great, thanks, Dave. And now Lieutenant Crenshaw with the 45th Space Wing.
Good afternoon. Currently, we have an upper-level disturbance over the central portion of the United States with a cold frontal boundary. We expect that disturbance to push the boundary into north and central Florida on launch day. That being said, the operational forecast, we're looking at some scattered to broken low clouds, visibility 7 miles, winds from the west 12, peak 17 knots, with some isolated showers and low ceilings being a concern. At that being said, 30% chance of violating our launch constraints. For the tanking forecast, we're looking at broken low cloud, no problems with visibility, winds from the west at 10 knots, again, a chance of thunderstorms, very slight chance of thunderstorms and coastal showers. Looking at temperature of 72 degrees at tanking time with a 10% chance of weather conditions violating tanking constraints. For the SRB recovery area, again, scattered broken low clouds, again, being a concern, 7 miles visibility. Winds from the north-northeast at 15 peak 18 knots. Isolated showers, air temperature 72, sea 75. Looking for a sea state height of 5 to 6 feet. For the 24-hour delay forecast, in the event that we do delay, scattered broken low clouds again, 7 miles visibility, winds shifting to the north-northeast, 12 peak 18, temperature of 74. With the wind shifting and picking up, that brings a crosswind concern for the 24-hour delay, and again, there's a issue with possible ceilings. So we're looking at a 20% chance of violating launch constraints for the 24-hour delay. For the 48-hour period, we're looking at scattered broken low clouds yet again, 7 miles viz, wind shifting more to the east, 050, 15 peak 20. Again, isolated coastal showers being another concern, and 40% chance of violating launch constraints for the 48-hour period. For the CONUS landing sites, basically no weather concerns to speak of except for the second day for Edwards. Some wind concerns. Winds are from the east, 14 peak 20, looking at some possibility of being a concern for that day. For the TAL sites, day 1, weather looking good for most places. Zaragoza, Morone, and Ben Guerir just expecting few to scattered low cloud. The winds from the west to the northwest, less than 10 knots. The second day, however, Zaragoza and Morone both are looking for a chance of showers within 20 nautical miles. Morone looks like they're expecting some broken low clouds, so there's some concerns there. The winds are picking up more from the west and increase to about 12 knots. For the day 3, looks the worst for the TAL sites. Zaragoza, again, chance of showers within 20 nautical miles, scattered to broken low and mid cloud. Morone, again, broken low cloud with a chance of showers. The winds picking up again, up to about 12 to 13 knots. For Ben Guerir, again, a chance of broken low cloud chance of broken low cloud. So at this point, we're keeping an eye on things, and hopefully Mother Nature won't throw a wrench into the works.
Okay, thanks, Tom. Let's open it up for questions. Start with Marcia Dunn right here on the front row.
Marcia Dunn, Associated Press. I was hoping to get a quick overview of the external tank door power drive situation for either Dave or...
Well, I can tell you a little bit about it. Let me give you a little bit of background. Each door has a single power drive unit. That power drive unit has dual motors. And our testing and preparation for each flight verifies that the door will close with this power drive unit under a certain time, and our requirement is it must close within 48 seconds. And we had an instance, one case, where the door on OV-105 took a little longer than 48 seconds. Actually, it took about 54 seconds. That's just indicative that maybe something's not quite right with the power drive unit. And since that time, we've been doing some inspections on other power drive units and doing some analysis. And really, that's what the pacing item is right now. These folks have spent a lot of time, worked the weekend. We have some inspections and testing going on in California, and we just haven't finished all that testing. We have some parts that will be tested tonight, and they're going to bring that information in tomorrow. And I would tell you, I'm very optimistic that all this is going to work out just fine. We have to give those guys a chance to finish their tests. I think that's going to work out fine.
And a question for Jim. Do you think that for the May 31st launch, can you meet that date? Is that a good solid date, considering you're going to be carrying up a new joint? And is there any outside envelope limit for time that you want any space station crew to be in orbit for? Since this crew will be setting a record as it is.
Right. We're working the schedule's coming very good on the joint replacement. The flight support equipment is being put together in Canada. We've already fit-checked that with the joint to make sure that it all fits together. We had to order some thermostats for the heater mats that sit underneath that device that'll fly in the cargo bay. Those thermostats are on order, and they will be expedited by the vendor to us and installed. So the schedule looks very good. I brief the schedule. I get to hear the schedule every day. There's a lot of near-term milestones, and they've been clicking those milestones off just one after the other. So things look very, very good from the standpoint of getting the passive unit installed in the cargo bay and then having the joint shipped down after the orbiter goes out to the pad and installing the joint out there. I haven't checked with the training guys lately on how well the training's going in terms of training the crew on the joint change-out. But again, I haven't heard anything, so I assume that's going pretty well. So I'd say we still are very much on track for the schedule that we've laid out for the 31st, and we'll see how that comes together. But I don't see anything that's changed from where we were before. It looks like a very workable schedule for us. And in terms of the overall crew duration aspect, I don't know if there's an upper limit or so. You know, we're above our planning limit. What we've seen on return crews is they've been returned in very good physical condition. The preventive exercise that we perform with the crew has been outstanding. The treadmill activities, the resisted devices, the cycle ergometers, et cetera, have all worked out very, very well. So we've talked to our medical folks about that, and we'll just kind of play that by ear and see how things go. But right now we don't see any constraints, or there's not a hard limit out there in the near future.
Okay, Jay? Jay Barbary with NBC. Ron, you mean a 24-hour delay. You mean a 24-hour delay in your decision, not a 24-hour delay in the launch. Is that correct?
Yeah, that's exactly right. We're still aiming for the 4th. And we just ran out of time, basically, for these guys to meet L-2. So we gave them another 24 hours and come in tomorrow and tell us the results of their tests.
And Bill, with the station, I read in 2 separate places that there are 9 additional truss units to the S0, and I'll read in another one that it's a centerpiece of 9. And looking at the outlay, I believe that's the way it is. Is that correct?
I'm counting up here in my head. I'm not sure I can do. I need a piece of paper, and I'll lay that out, and then I'll tell you which way it comes out.
The solar arrays that we have up there now, they go on the end of the truss, the structure, when it's finished, correct? When do you plan to move those over, and how are you going to do it?
That's the 12A.1 flight, and that's done by using the Canadian arm, which picks that element up. It then sits on top of the MBS, which is launched on the next flight, UF2, which sits on top of the mobile transporter, which is on this flight. And then that entire truss segment trundles down to the end of the truss and gets installed out at the end. So we roll the arrays up, the arrays are stowed, and then there's a lot of activity associated with that. We have to pre-position and move some of the radiators associated with that. That's going to be one of the more exciting and dynamic activities coming up in our future. And we're busy working those flights. They all show up in the 03 time frame, and we're working very hard at understanding those flights and getting everything understood and getting ready to go support those activities. But again, the ARM is key to that. The mobile transporter that's here is key to that. All these things are kind of serial in nature. We need the ARM, we need the mobile transporter, we need the MBS to do these activities.
Thank you. Stephen?
Steve Seislaw, Florida Today. Ron, I have a couple of security questions for you. First of all, do you feel safer with this mission because the exact launch time is somewhat secret until 24 hours?
I don't feel any different than I did the last mission. It is, from my point of view, it is the same. The security is just fine. It's acceptable to me, and I'm supportive of the policy.
And do you know of any specific threats? Have you been warned about any specific threats against this mission or any future missions?
I think I'll just stand with what I just said. I feel very safe and secure.
Thank you. Other questions? Okay, let's go to Jim Banky down here in this row.
Yeah, Jim Banky, Space.com. I guess for Ron or Dave, on the ET drive unit, could you just clarify that the hardware on Atlantis you think is good, and maybe review when it was last tested? And again, if there are any tests that need to be done with the pad, how would you even do that given its current configuration?
Yeah, there's no plans to do any testing at the pad. What we're really doing is we're looking at our inventory, and our inventory encompasses and envelopes the hardware that we have on the pad. So we're able to test that inventory and get a good insight into the pedigree of what we have hardware-wise on the pad. And our preliminary results of this testing are favorable. And like I said earlier, all they needed was a little bit more time to complete their planned tests.
In the testing that we did in the OPF, we did test this hardware like we normally do on every given flow in the OPF, and it was well within the limits, well within the family.
And a question on the maintenance, maybe for Dave. I don't know. You hint at stretching this stuff out and not taking the orbiters out for big blocks. When would you want to start that? Would you start that with Discovery right away? Would it fly sooner, as it were? Or are you going to do this whole block in one shot and then start spreading things out?
Right now we're planning to do this orbiter the way we have done the others at Palmdale, but we're just going to do the work here. But we will be looking at how we can incorporate all the things that we want to do to the orbiters, and we have more options now than we had in the past, but it's probably not going to affect 103 greatly.
Nor 105. 103 and 105 both get meds coming in their flows, and once the meds are in, then we'll look at a different way of doing business. Thank you. Stefano?
Stefano for the Popular Mechanics. I was wondering how the new engines are going to improve the overall reliability of the shuttle during launch. I know that you have a number that is 1 in 400 or whatever possible accidents during launch. I wonder how this is going to improve that number and by how much.
You know, I should know those numbers off the top of my head. I don't today, but our friend here can give you those numbers. Let me just characterize it subjectively. These pumps that we're flying, you know, we put the high pressure oxidizer pump on some years ago, and we've had 2 flights with the high pressure field turbo pump, and this will be the first flight of a cluster of 3. These pumps are fantastic. As I've monitored the testing and their robustness, it's amazing to me what we have done to include safety features. You know, we've basically eliminated the welding inside the pump that we could not inspect. We've made the pump beefier, more robust. And because of that, we've accepted about a 300-pound weight increase per pump. But we wanted to do that intentionally sacrificing some performance to improve our safety. We've witnessed in testing, we've had a couple of problems in our testing. They weren't intentional, but because of those problems, we've seen the real robustness of the pump. In the past, some of the failures that we have seen on this new pump would have taken out a pump and an engine in the past. With this new pump, it just keeps on chugging. It'll run to MECO or it'll have a graceful shutdown. So just subjectively, it's a tremendous improvement in our safety.
Do you expect to use these engines at 109% at any time?
That is something that we are continuing to study. And as we get more run time and test time on the engines, we'll certainly have that discussion within our panels. Phil?
Phil Norton for Ron. Let me clarify on this ET door. Is it the one on the shuttle with the 17-inch disconnects, the one where we had the issue with the hinge cracks back on the STS-110? And could it be related with anything like that, or is it just a motor mechanism?
This is associated with the power drive unit solely. I mean, it's the units, the torque limiter that takes the door. You know, you got the bottom of the vehicle and the door sits flat, and then you drive it down through 90 all the way up to 180 to close. And it's the drive mechanism. It's the power drive unit that closes the door. That's all it is.
And for Bill, let me follow up on Marcia Dunn's question. The next flight coming up where you do have the hinge replacement is the crew exchange mission. And what do you do if there's a 2-3 week delay? Obviously, the worst case scenario is to send the crew home by the Soyuz and leave the space station unmanned. And I obviously don't want to do that, but at what point do you have to make that decision or start thinking about making that decision if there is an issue with 111, or even if there's a non-related issue like RSLS aboard or something like that that delays the flight?
We'll just continue to take a look at our overall schedules, and as we start eroding on the schedules, we'll go back and talk to the medical folks and make a decision about what we go do. We have a couple options there. You know, we talked about you know, whether we really need to change the joint out depending on what the failure is. We could reevaluate that again. If there's an orbiter problem, then clearly we're going to go use the Soyuz as we've discussed. But we'll go work that out, work with whatever the situation is, and take a look at it and figure out what the right plan of action is.
Okay, thank you. Mark?
I'm Mark Carreau from Houston Chronicle. I had one for Ron Dittemore first. Are the drive units on these doors redundant? Are there 2 drive units on each door, or are you just looking at having one?
There's 1 power drive unit per door, but 2 motors per power drive unit. So the redundancy is in the motor, but in the gear train, that's where you would have a single point failure. But we're not having any issue with the gear train. We're just making sure we have the right torque being applied to the door. And whether it passes at 48 seconds, and we call it not so good at 54. And so all that does is it points to you to go look at how much torque we're delivering to the door to close it. Even with that 54-second time, it closed the door fine. It's just an indicator for us to start looking and evaluating to see if there's anything there we don't understand. So I would characterize it as the door closes fine. We haven't seen anything that would cause us an alarm from the power drive unit point of view, but we are digging a little deeper to make sure there isn't something there that we don't quite understand.
And did that longer time, so did that happen in flight, or was that a ground test?
That was a ground test on OV-105. In fact, on the power drive units, the most severe test it ever sees is closing the door during the test on the ground. And everything, once you launch, is a lot easier than what we do on the ground.
Okay. Mark, one more?
Yes, for Bill Gerstenmaier. I just wanted to follow up on the attitude control problem over the weekend on the station. Have you had a chance to run down what happened there? Is that any issue for this mission or any long-term problem?
We took a look at that. Our primary GNC MDM or computer failed on Sunday about 2 a.m. And when it failed, we handed over just as we anticipated attitude control. Then we brought up the redundant computer, and it's up and operating fine. We then rebooted this secondary attitude control computer. It came up, and it's operating fine now as a backup. So it's, we think, some kind of transient event. We're taking a look at it to see if there's anything in the data or telemetry that indicates that it's more than a transient event. But at this point, we just say it's a transient event, and we're still trying to determine what the cause was. Again, it was fairly inconsequential. We had the proper amount of redundancy in the system, and we were able to reestablish attitude control very quickly, and it's not an impact or consideration for this flying.
Okay, thank you. Peter?
Peter King, CBS News Radio. This is for Mr. Gerstenmaier. In your best layman's terms, would you explain what the trust does and what, if there is an earthbound analogy that you can use, that would be all the better. But why it's so important, why it is the cornerstone to the space station here.
I think the simple way of looking at it is if you see the pictures of space station, you see the solar rays all the way out on the end, right? And right in the middle, the way that all of that material attaches to the lab is through this central piece, is through this S0 truss. So in simple terms, it truly is the cornerstone. All the structural loads, all the solar rays, everything hangs off of this in the way it interfaces to the laboratory module. So all the loads go through there. You'll see the thermal radiators. They come up on the next series of flights on the S1 and P1 flights. Those have ammonia in them. All that ammonia gets plumbed through this central piece, then routed to the laboratory module. So it's kind of just it's the central switching unit. It's the main interface between all the other elements. It also contains a mobile transporter, which is our crane, which we described, which can run the entire length of the truss up and down.
And instead of asking you how many pieces there, when do you anticipate? When is it scheduled to have to be all the way out, all 8 or 9 pieces or whatever?
Through really, we kind of look at the way we build up space station, and it kind of culminates with the Node 2, which is delivered now. We're targeting for around February '04. So all the truss pieces will be there. Then Node 2 will be there. And then that's in February '04, and then we add the international partner modules after that. So we see that as kind of a key milestone of the station, that the U.S. core complete station is built out at that point and then ready to go forward.
Okay, Vic.
Vic Radner from ABC for Mr. Gerstenmaier. What improvements have you been able to make in the noise level on board the space station? Do the astronauts still have to wear earplugs? Have you reduced the noise? What kind of noise levels are you getting at the moment, and what plans do you have to improve it?
The crew members do wear hearing protection in certain modules. What we've done is we've looked at the various modules on board space station. The most noisy module is the FGB, the functional cargo block, delivered by the Russians. We had originally planned on trying to quiet that area, but now when we look at it, that's an area that you transit through. It's kind of like a hallway. You don't spend much time in there. You're not active in there. So what we've decided to do is concentrate our noise quieting efforts on the other modules where the crew spends most of their time, because the noise problem is a function of time in a module and exposure to the noise. So we're looking now at making some mods to the service module. We put some insulation and quieting devices in the air conditioning ducts and some of the systems around the compressors and pumps. That's helped some. We're continuing to work with the Russians now, and we're going to make a concerted effort to work on the service module. We're also working very aggressively on lab payloads that come up, and we're looking very aggressively at the nodes, and those will be pretty much back within the standard specifications that we want to design.
Levels up in the 90 to 95 decibel level?
I don't recall the numbers. I don't believe they're that high. I think they're maybe 60 to 70 dB, but it's a function of frequency, and I don't recall numbers as high as what you just quoted to me.
Okay, other questions? Okay, Mike.
Mike Cabbage with the Orlando Sentinel for Ron Dittemore. Could you talk briefly about the progress of the groups that are off looking at shuttle privatization and outsourcing, and talk a little about what sort of milestones are coming up in the next few weeks and months?
Yeah, I believe I talked about that a little bit the last time I was here, and not much has changed. There still is a group that is evaluating business opportunities, market analysis, types of subjects and questions on whether privatization or competitive sourcing is the right approach. That group is scheduled to deliver a report in the midsummer time frame, and I think that's the next major milestone for us. We really need to understand the framework from a market analysis, business acumen point of view before we take the next step.
And what is the status right now of renegotiations or of an extension of USA's contract? Where are you at with that right now?
Well, as you know, the contract as originally signed was for 6 years with two-year options, and we are working right now on the first of the 2-year options, first of 2, and we plan to have that settled by September.
Okay. Bill?
With CBS for Ron. What sort of failure did you have with a hot pot from Pratt & Whitney that would have taken out a Rocketdyne pump? I remember a couple of instances reading about some problems, but I wasn't aware of one that led to the situation you're describing.
I need to show you some pictures of, and I don't remember right offhand what precipitated the event, but the engine actually ran for a good long time on the new Pratt & Whitney pump, and I'm talking field side, and I don't recollect whether it reached a cutoff limit and then was shut down gracefully, or reached the end of test. It was one of the two. But as we tore the pump apart and looked at it, it had a significant amount of blade damage. In the old pump, if we had blade damage or lost a blade, it was pretty much a catastrophic event. It just could not stand losing a single blade, and that was because the pump was designed to be lightweight, and it was very tuned to be lightweight and high performing. And so when it got out of balance by losing a blade, it just kind of cored itself out, and that became a catastrophic event. With this new pump, it's very robust, and its blades are hollow, if you want to think about it that way. So I can lose a blade or multiple blades, and it doesn't send my pump out of balance. And so I'm able to withstand those types of events and those types of failures and still have a graceful shutdown or make it to the main engine cutoff.
And just one more on that, and I just didn't follow up after the last time. I guess you flew Block 2s 2 times, and once you had a pressure spike in the MPS, it shut down, and obviously it didn't on the second one, but I'm just, you changed the sequencing of the, I guess, of the post-shutdown purge or whatever to eliminate that, and that's why you're confident to go fly.
That's exactly right. We put a 2-second delay in that, and we tested again on, gosh, what vehicle was it? We flew it one other time, and now we're ready for the cluster. I don't remember what flight it was. We flew that second one.
Okay, let's go back to Peter one more time.
Peter King, CBS News Radio. And this is for Ron. You mentioned before that 300-pound additional weight for each pump. I'm just wondering, did you have to take that weight off elsewhere in the shuttle, or don't you have to make up for that?
Well, we had invested a lot of time, effort, and resources in going on a diet from a weight point of view, and part of that was driven by my good friend Bill's desire to launch heavy stuff into station orbit. And I believe we, in our dieting effort, lost about 17,000 pounds. And in that dieting, we added back 300 pounds per pump, well, you know, about 900 pounds for the engines. And so we overshot Bill's requirement a little bit so that we had room to grow if we had the occasion to do so and improve our safety.
Okay, let's bring it back up here for just a couple more questions. Let's go to Marcia. I believe you got one.
Marcia Dunn, Associated Press for Ron. I was just curious, looking ahead to July, does July 11th seem like a feasible date with the extra work we're going to have to do with the cooling loop on Columbia?
What we're doing on that, we're not treating July 11th or STS-107 as a single decision point. We're grouping 3 flights together. It's the July flight, the August, and the originally planned September flight, and we're treating those as a package. And we're asking United Space Alliance and our team to evaluate what is the best launch dates for the 3, given the spacing that we need, given the fact that we have some problems, like you mentioned, turning the vehicle around and having to account for the Freon loop deservicing. Also, we are engaged in making sure that we understand that we have the right people at the right places to evaluate the time between landing and launch of a vehicle. So not only are we looking at the spacing between flights, we're looking at the spacing between landing and launch. And we're going to evaluate that on April 11th and try to make some decisions with respect to all 3 flights as a package.
Jim?
Yeah, JimBankeySpace.com, and Ron, I'll talk to you afterwards about that shuttle diet. Could you talk, at the risk of over-dramatizing the whole ET door thing, I understand you want the door shut, you know, for re-entry and that you've got EVA standby. Is there a constraint, though, once you're on orbit for getting it closed by a certain amount of time, or can that thing stay exposed to vacuum forever?
Well, it can certainly stay exposed to vacuum, but we don't have an EVA backup to close the doors. The doors have to close. We have dual motor redundancy, and the gear train is a mechanical gear train, and it just has to work. And so there would be really no instance where we believe we wouldn't be able to close the doors in the proper time. That would be soon after we separate from the tank, both in the nominal case, and certainly you have to understand that if we were on a TAL abort, you would have to get those closed fairly quickly before entry, and on an RTLS. Now the RTLS is the most benign of the three because you're not as high in altitude and your heating isn't as great, but it's still to the point where it's a criticality 1 failure mode for us not to close the doors. And we really don't have any procedural or operational workaround. So these motors, this power drive unit has to work.
Thank you. Phil, you had one?
Yeah, Phil Chen for, I want to take this. With the current security rules of not revealing the launch time until the day before launch, how different is it dealing with your workers, emphasizing that while it's not classified, it is considered sensitive and for in-house official use only, and they shouldn't tell their family, friends, neighbors, or whoever's what the actual launch time is until it's officially released, even though a lot of people already know what it is.
Well, Phil, I think the impact is on you and not us. It doesn't change my life one bit. It doesn't change my products. It just changes your knowledge of the launch time. It does not change the team's approach one bit.
Thank you. Stephen?
Steve, Seislaw, Florida today. Again for Ron. Is there any word yet on increasing your manifest for either 03, 04, or out beyond that, beyond station and Hubble flights?
Well, we are certainly working through a budget process of a flight rate that's basically 4 flights a year. And Bill and I and Tommy and I are working to understand what should be the most appropriate flight rate. And that series of studies and evaluations is ongoing, and we expect to come to grips with that in the midsummer time frame.
Okay, we have time for one more question, and Jay, I'll give that to you.
Jay Bradbury with NBC. Ron, can you give us any feel for the scheduling of these 3 missions, July, August, September? Is it moving a month, 2 weeks? What can you tell us?
I would think that on the July flight, it has a threat to maybe move a week. August flight, maybe a week. The September flight was scheduled for September 19th, and that has the potential to move a couple weeks at a minimum. The one that will have the most impact will be the September flight. It's the 3rd in the row. It's gonna have the most, I should say, it's got the least amount of attention in the beginning because it's the last of the 3, and so it's probably gonna need a little bit more time to get pulled together. So it can be either early October, or it could be as late as November.
Okay, thank you, everyone.